All right, here we are. So we are getting back into things and we are going to continue working on our little NVIDIA Nano here. Wait, hold on. There we go. Okay. So we connected it to this speaker. Oh, I am a little bit tangled up. Okay, speaker, microphone right there. And what we want to do is be able to get this device to be able to both talk to us and or we want to be able to talk to it, have it process its LLM, what we said to it, then get it to respond back to us. That's kind of what we want. We want a conversationalist right now. Then later we're going to be adding in the extras of like uh, the tool usages, and we'll figure out how we can make it more interesting. But as of right now, we're just trying to do a conversationalist. So let me actually start powering this one up. So here we are, and let's get going. All right, power it up and plug it in. Come on now. Here. Woo. All right. Now we do this and we should be connected. Okay. So, right here, I can see if it's already booted up. And what we did let me make myself a little bit smaller. All right, come on. Come on. There we go. So, what we did in the last video was we were working on Piper and getting it to be able to communicate from just a basic string. So I just say, hello, my name is Timothy Grant. Getting it to communicate from that and have it actually run that command or run that the phrase through the speaker and talk to us. So what we do is we echo the text that we put in, right? That's that string. And then we pipe that over to the path to the Piper executable, and we give the model path. This is going to be the language model itself, okay? And then we put the settings right there. Okay. So that's kind of how we were doing this speech portion. And now the next part is going to be I kind of want to be able to mesh things together. So I want to be able to have a program which will listen to me, take in my text, put that text into an LLM, get a response back. So I want to be able to do that. Now, that will be maybe something here, right? So a new file, not in example agents, but I mean like a new thing here. So new file, and what should we call it? Chat agent 1.py. Okay. Is that good? Sure. All right. So now what I want to do is we need to meld together the different agents which we have created. So first step is going to be we want to come to this Jetson example and almost copy over what we did. So let's do that. Let's copy this over to here and then see what we want to take and see what we don't want to take. Okay. So role and system. As of right now, I don't think that we really need this We just want the friendly AI companion. We don't need this tool determiner. Okay. And I can actually just, yeah, so there's a lot of stuff that we'll probably not need right now, but it's fine. Let's put everything together. Here, this will just be the speak. Okay. So we'll need a function just called speak, and we can put those there. Okay. Then transcription, audio recording. All right. So now we will need this same thing. This, and we will need to put this not there, here, right? All right, so now this is obviously a mess right now, but we will. All right, so git add git let's see, what should we call this? Created a new chat agent Python script to have all three components which were previously experimented on, period. First is the LLM as an agent, comma. The second is the microphone which listens to the user speaking, comma. The third is the speaker which can output voice back to the user, period. Okay. So there we go. All right. And now we are able to experiment with this a little bit more because we have now saved it. Awesome. So obviously there are going to be some problems with this because we are we just like melted everything together. So that's not what we really want to do. So I want to come down here. So we're going to be doing this while true. Okay. So let's put all of our import statements together. Okay. We go. Now our model path actually can fit kind of right there. That makes sense. Usually I would probably put it up there before the function. So let's do that. All right. So these two are going to go up here like that. There we go. Okay. So this one we are no longer using. We can get rid of. This speak, this is going to be a helper function, and it's actually working right now. So that's fine. I don't think we really need to mess with that one too much. Okay, so this one here, we are also going to need to move up. Okay, so let's move it right here. Okay, so this is, I'll just put a comment, audio, that's actually correct, that's what I wanted, but I don't like Copilot. Okay, fine. It's actually legitimately what I wanted. Recording, fine. All right, so this is another helper function, right? So that's going to be fine. This is going to be fine. This is going to be fine. Okay, so this is kind of where we need to do things. We don't need this anymore, but I want the structure of it like this. Okay. I want to see the structure that way we know how and when to call it. So we have this here, and this is where we're actually going to be doing our this is where we are going to be doing our chatbot loop. Now, we actually do need to change it a little bit because what's going to happen is we are actually going to be needing to listen to the user through the audio instead of having them type something in, right? So instead of this, we need to replace this line with getting input from the user. So I need to, well, first off, I'm gonna snooze my Copilot because it's gonna try to take things over. But I'm gonna go user input is equal to, and now we're gonna use one of our helper functions, right? So what do I want to do? I want to be able to have the user, to have the user be able to press the button, press like a button and start the recording. And then they need to also be able to stop the recording, right? And as of right now, the way that we deal with that is we do like a keyboard interrupt is how we stop, which is obviously not what we want to do. So let me go back and look at this. So we get the USB device index. Okay. Record the audio, transcribe it, and then we get the user input. So kind of need both of those here. Like this, but then get rid of this. It's not text anymore. Now this is the user input. Yeah. Like that. So transcribe. How are we doing this? I need to go back and kind of remember how we were getting all this stuff. So we need to downgrade it to the 16K. That makes sense, but we're getting it from this path. So we're storing it in our actual like location, and then from that we're grabbing it and putting it through Whisper. Right, we're getting the audio file first. I remember that. So what's going on here is we are first recording the audio, which saves it as a like .wav or whatever it is going to be type audio file, and it's like 48 kilohertz. Then we are going to be going and looking at that path and transcribing it through Whisper to be able to get the to be able to get the words which come from it. Okay. Then we just like return that back. Okay. So the other thing is I know that I'm going to need to get the USB index. We need to do that. So that needs to be a global thing. Okay. Get USB index. Now we have this here. And where is my get index? Okay, so this is going to find out where it was enumerated. Okay. And then we come in here and do this. Okay. So now, what is the point of this? We need to wait for the user to initiate a speaking command and then get their audio and have them give another command that they are done recording. Period. Okay. So now the problem that I'm thinking is, okay, well, I can do just like kind of like an infinite while loop right here. I can do kind of like actually let me come back and get this. Like I can do something like while can I do it this way? While input here, because this returns, is not equal to, or is equal to none. So pass. Is this a blocking or non-blocking? I might be able to, if this is non-blocking, I might be able to just actually do this. Like, instead of having this, I can just say user input here. So I'll say text command is equal to input here, and then if text command is not is equal to Q, exit. Okay. Otherwise, we're going to come in here and start transcribing. Okay. That obviously does assume that this input is blocking, which I'm not sure about right now. The other thing that we need to figure out, though, is, okay, let's say that it is blocking, and now we're going to be coming up here and waiting for a keyboard interrupt to occur. I don't like that. Like, how do I go and figure out how to be able to get it to be able to stop based off of kind of what the user is doing? because it will catch the error here, and we don't necessarily need to make it crash, right? And so we are able to actually use the Control C, but I don't like needing to do Control C every time I want to end my sentence. I'm kind of curious, like, would this even run though? So let's copy it and let's paste it into, let's see if it will even run. So we're gonna go into desktop and then agentic AI. Okay, hold on. Okay. I thought that I see what's going on. Okay, so I am going to do SSH Jetson. I thought that I did. Oh, right, it just failed. Okay, Jetson. There we go. And I hear Susie texting me. Let's see. I think she was saying about Grok is very positive. But anyways, so let me go into my desktop and then AI. There we go. Now it makes more sense. And I want to actually make a new file in here, right? Okay, so I'm gonna go and do cat piped to chat agent 1.py. Okay, and then we're going to paste this in, and then we're going to do Control D here. Okay, awesome. So now let's see if we can even run it. Python 3 chat agent 1. All right, so now what I want to do is I want to, I'm going to press a button and press enter, and that's going to get me into the loop that will, it will get me into the loop which will start listening. Then I need to say something and then press Control C. Let's see if that works. Hello, are you able to hear me? My name is Timothy Grant. Let me know if you are capable of having a conversation with me. Okay, so let's see. Okay, nope. Well, it's trying to invoke a tool, so that's awesome. Okay. All right. So nice to meet you, Timothy Grant. Okay, so yes, it did hear me. It did send that to the It did send it to the LLM. Okay, actually this is quite I must say, however, that I don't have the ability to perceive or interact with the physical world, so it's unlikely that I could hear lights or. So this is because the tool invocation was trying to invoke the like status of lights, but the main functionality is actually kind of working in terms of it's listening for me and it is correctly able to so I'm able to talk to it through my voice, and then I am able to send that to the LLM. Now it's invoking the tool incorrectly, but that's actually kind of fine for right now. We're gonna fix that. Git add commit. I am now able to successfully use my voice to record a message, and that message is sent to the LLM and responds back in the form of text, period. I need to press any button as an input to start recording, comma, and I need to use Control C to stop the recording, period. In the future, I will need to figure out how to make a more clean way of starting and stopping audio recording, comma, I also noticed that the tool was trying to invoke the tool selector was trying to invoke the wrong command, the wrong tool. Oops. For a conversation which did not require any tools, period. I have not tried turning the LLM's output into speech yet, period. Okay. So, go. Okay. There we are. So, cool. Now, what do I want to do with this? I want to now try to do this transcription. Okay. So, if I come here and I get my thing, so print the response here. So instead of printing the response, what I want to do is I want to transcribe it. No. I want to speak it. So that's all I should have to do is just do speak and then text, right? I think. So let's try this. Speak and then response dot message content. Okay. So we're going to save that and we're going to come in here and we're going to Control C now out of this and chat agent here. Okay. So now we're going to come down here and just add that one line of code and hopefully things will start speaking. Okay. All right, come on. Okay. So speak and response dot message dot content like this. All right. Right, quit, and let's do the exact same thing. I'm curious what your name is. I was just trying to become friends. All right, so now it's sending it to the LLM model, and we'll see if it is able to speak back to us. See, it's using the temperature and room thing again. Like, that doesn't make sense. Uh-oh. Uh-oh. Okay. So raw data std in. Okay. Signed 16-bit little Indian, whatever this is, 22K, so 22 kilohertz. Runtime error, model configuration does not exist. Okay. So speak is angry. Did it do print? It didn't even do print speaking, did it? Playing raw stdin. Echo here, right? So we're doing that shell script, which just runs this string of text, but we should have at least seen this print statement, which is kind of weird. Is one of these incorrect? So we have this kilohertz right there, so that's the same thing. Let's run this A play again and see what we can find. Actually, let me run this. Let me copy this. Okay, because we're going to be putting this into the LLM. That. But I now want to come in here and figure out, like, these are absolute paths, so it should be fine. So I don't see anything wrong with that. These are absolute paths, and we're not having any problems with Whisper. It's Piper that is going wrong. Output raw. Okay. Interesting. So copy you, and now put you in here. It seems to be working properly, but the problem that I'm getting right now is that when I attempt to invoke the speak command, I'm getting an error, period. Do you have any ideas? Question mark. Okay. Model config doesn't exist. Comes from Piper, not your Python logic. Yes. Look at this script very top. Yeah. Okay. What happens when... Oh, come on. Okay. Piper. Okay. How ridiculous am I? Transcribe. Where's my speak? Where is my speak? Okay. Okay. There we go. And we should probably get this one as well. Model path. So where are you used? Only one other place? Model path and then just whisper. Or whisper model path. Oh, wait, hold on. Whisper path, model path. What's the... Okay, I don't want to be changing too much right now. Okay. Yeah, unique variables. Yeah, this is a huge milestone. It's reasoning, but actually it's incorrect. Cleaning up the... Complaining because it's searching for every possible output that doesn't exist. These are harmless, but they make your terminal messy. Alright, so we can redirect them to standard error. Okay. I was able to fix the conflicting variable name, comma, but now I have a couple questions on your suggestions on how to go about making my code better, period. I am currently taking in any input which the user gives to me, any input from the keyboard as my cue to start recording audio, period. audio, period. And then I will rely on a Control-C command for the user to stop the audio recording, period. What do you think of this? Question mark. Can you think of any ideas for how I can do this better? Question mark. All right. What were some of the other stuff? Then we also need to work on the incorrect invocations, obviously. And then we need to. It really wants the sliding window. I remember that, but we're not going to be doing that right now. The other thing is the question which I asked actually did not require a tool to be invoked because I was just asking about how the model's day was going, period. So I think that this was an incorrect thing for the model tool selector to invoke a tool, period. Okay, so we'll see what that does, and let's come in here and copy this, come back in here, and then do the same thing of this, right? Paste you in there, and then Control D, and now run you. I feel super tired today. How are you feeling? Okay. Status of lights in room. That's not.
Sorry to hear that you're feeling tired today. As for me, I'm doing great. Thanks for asking. But let's talk about something more important, your energy levels. Since all the lights are currently on as per our shared knowledge base, it's likely that it's daytime where you are. Maybe we can find a way to boost your energy with some fun ideas? Shall I suggest some ways to help you feel more awake and refreshed?
Oh my goodness! That is amazing! That is so cool! That is amazing! I love that! It's working! Okay, okay. So now we need to. Okay. So yeah, I can get rid of this actually. Okay, I can get rid of this here. Actually, what I could do is come in here and do this. And then do this. And then do that. There we go. Okay. So I can do this, and now we need to actually tool determine or prompt. Determine if the user... so I think that these are not strict enough. Okay. So the trigger happy tool selector. Your LLM invokes the temperature tool even though you asked how the day was going. This is a common issue system. All right, so you gave it a very strict if-then instruction. Determine if the user is asking. If they don't, mention hot or cold. If they mention being hot or cold, use the temperature tool. Because the LLMs are designed to be helpful, they often overinterpret instructions. If you say it is a beautiful day, the LLM might think, day relates to weather, which relates to temperature. Okay. You need to Give the LLM an escape hatch. Update the tool determiner to include a none option. Okay. So let's look at this and then try to figure out what we want to do. So we have the tool determiner, right? This one is the friendly LLM. We don't want to touch that one. Okay. So yeah, tool determiner prompt is going to be now an array and a dictionary. Okay, that's what we have already. And the role of system, the content here, right? And I need to fill out. Why did I have this part? Let's see, where do I use this tool determiner? Do I only use it down here? Okay, so I'm grabbing the content of the user input. So I'm grabbing this. Okay, so what I want to do is just copy and paste this. Okay. Then I want to change this to old. Okay. Old. And then I want to copy this and put it here. Okay. Like this. Alright, so let's see if this, so if the user is just chatting, making small talk, or asking about the day, do not, okay. Alright, so copy all of this, and we are back in it. So come here, paste that in there, do this, and we'll try it again. What do I want to say? I'm curious what your favorite type of engineering is. What do you enjoy doing? There we go. All right, this is taking a little while.
That's a great question, and I'm glad you asked. As a friendly AI companion, I don't have personal preferences or feelings like humans do, but I can tell you about some fascinating types of engineering that people often enjoy. Some popular types of engineering include 1. Aerospace engineering exploring the vastness of space, designing aircraft and spacecraft, and pushing the boundaries of human innovation. 2. Biomedical engineering combining engineering principles with medical science to develop innovative solutions for healthcare and improving people's lives. 3. Renewable energy engineering working on sustainable energy systems like solar, wind, or hydropower to reduce our reliance on fossil fuels and combat climate change. 4. Robotics engineering creating intelligent machines that can interact with humans and the environment in creative ways, from self-driving cars to prosthetic limbs. These are just a few examples, but there are many more exciting areas of engineering out there. What about you? Is there a particular type of engineering that interests you, or perhaps an area where you'd like to learn more? By the way, I'm happy to chat with you about any topic, including engineering or any other subject that's on your mind.
All right, great. Second thing is I want to figure out, can it actually talk in Chinese? So, 嗨，你好，你会说中文吗？那如果你会说中文，我们应该聊天任何的话题。你有话题想聊天吗？ All right, let's see if it can do that. If it is, I'm going to be pretty impressed, but I don't know if it can. Okay, status of lights. I should have done some debugging things to see if it was even able to capture that it was in Mandarin.
Nai hao. Hello. I'd be happy to chat with you in Chinese if you'd like.
Okay.
While I can process and understand some basic Chinese characters, my proficiency is limited to generating simple responses. However, I can try my best to communicate with you in Chinese. Let's get started. Here are a few phrases to help us begin. Asterisk Nai hao. Wo jiu I name hello. My name is I name. Asterisk zai zai thank you. Asterisk Jang duo ha bu kai I'm happy to chat with you. If you'd like to have a conversation in Chinese, feel free to start by asking me a question or sharing something about yourself. I'll do my best to respond. And don't worry, I won't take the lights too seriously. I just noticed they're on because you mentioned it.
Okay, well, so we got the lights again. So that didn't work. But the Chinese was actually kind of interesting because I spoke in all Mandarin, right? And it was able to understand, it was able to identify that it was speaking in Mandarin, and it then also understood what I was saying in Mandarin and responded correctly, but in English. And then the Chinese, like when it was talking, Nai Hao, like completely incorrect. So interesting. Okay. I guess what I will now want to do is possibly get, I might need to get a, like, I might need to determine if we're talking in English or Mandarin, and then based off of that, send it to a different type of model or something. Let me try actually speaking to it in a way that I don't mention anything with Chinese. So 今天我真的是很累，我就是想睡觉。那你也有这个感觉吗？ So I said that I'm really tired. Do you feel tired as well? Kind of like that feeling. Let's see if it's able to.
It sounds like you're feeling quite exhausted today. Yes, it's totally normal to feel that way, and sometimes all we want to do is curl up in bed and take a nap. As for me, I don't have feelings or physical sensations like humans do. I'm just a computer program designed to process and respond to text-based inputs. So, I don't get tired or feel the need to sleep. But I can certainly help you relax and maybe even suggest some ways to unwind. Would you like some suggestions for calming activities or soothing sounds? By the way, thanks for letting me know about the lights being on. It's always good to have accurate information.
Okay. Well, I mean it's working, right? It is working. Okay. This is not working. The control C, I mean it is working kind of. Instead of a while loop that requires this, use a non-blocking enter to start. Presses enter again to stop. Okay, it doesn't throw a traceback area every time you stop talking. So monitor your root mean squared loudness. I don't really want to do that. I kind of want to do this one. Sounds better. Push to talk. Option C sounds good as well. Saving to disk, converting here. This feels competent. We may optimize. Okay. I can change this directly. Okay, good. Can you show me how I would do option A and how I would do option C? Question mark. Can you explain more about how I would be able to combine the ear and mouth? Question mark. Okay, so I'm going to do this. This is number 2 right here. This one is going to be number 1 right there. And now I also want to say number 3. Now that I have my entire system kind of working, I want to be able to determine how much more space I have, because what I'm thinking about doing is I think that my model is too small for the requirements of finding the correct tool. So possibly I need to upgrade my model, period. What are your suggestions on how I can go about finding how much room I have left and how I can choose a better model? Question mark. There's another thing that I want to do, which is be able to have the model respond to me in Chinese, so I also might need to have some kind of Piper or Whisper for Chinese, period. Although it seems like it is able to... Hold on, this is going to be a... So this is actually going to be 4 right there. Okay. Able to understand me when I speak to it in Mandarin, and it responds correctly according to what I'm saying, but it responds back to me in English, period. So this actually is Whisper right here, right? But it's kind of different, but not... It's different insofar as this is connected to the actual company. But let me just try speaking in Chinese. 如果我这样说话，你能听懂我的意思吗? Okay, so that's actually... It's correct. It's traditional Chinese right there, not simplified, but that's fine. Okay. Alright, so A and C. So option A is the intertoggle. This uses non-blocking thread, so the program can listen for a second enter key while the audio is recording. Okay, so we will need threading. This one is like push to talk. Alright. So on press, on release. So these are probably going to be like events or something. So with keyboard.listening, on press, on release as listener here. Okay. So let's we can try this as well. Control C out of this. And now df minus h, was it? And from the root, okay. No. I don't think that, okay. Well, this is my SSD. This is not my RAM. Okay. For RAM, run JTOP. Oh, JTOP, the problem with this is I can't actually do anything with it because I can't copy and paste from there. Okay, let's we can just try JTOP, but you'll see what I mean. It's like a graphical user interface, see? Okay, so CPU here, GPU, these are temperatures. Now I should be able to do 2, which goes to GPU, memory here. Is this RAM? ZRAM here. Used is 3.6. And we have free is not very much. GPU SH, I don't know what that means, but I can't copy and paste this, see? When I do the JTOP command, I go to the MEM section and I see something which says RAM, period. I see used as 3.6 G, comma, GPU SH as 2.7 G, comma, buffers as 36.8 M, comma, cached as 3.2 G, comma, free as 633 M, comma, TOT as 7.4 G, period. Okay. So I don't know what this cached means and what the GPU SH means, but those are taking up a fair amount. If that's my LLMs, I actually have a lot more breathing room and I can kind of get rid of those. So maybe, who knows? Okay, so let's kind of look at these things here. So escape. There we go. Okay. So now what we want to do here is, it's difficult to get everything so that we can actually click on it. Okay. So for this one, this uses non-blocking thread so the program can listen for a second enter while the audio is recording. Record until enter. Okay. Listen for stop. Okay. This one is going to be in my main loop. Okay, I don't really understand how or why we're doing that. So we're creating a new thread in here. Starting the thread, okay. Right now I'm just trying to think about what might be the best way for like a user experience, but then also what might be kind of interesting for learning. Okay, we can do this. Choosing a better is great for tool calling and responding. But for tool calling, so we can do Mistral or Quinn. Okay. Very strong at multilingual Chinese tasks. Okay. Excellent at following logic instructions. Interesting. 7 billion model would take up 4 gigs of RAM. Since Whisper and Piper use almost no RAM because they're C++ binaries, a 7 billion model would fit. Okay. So here, Whisper, the base.bin model you're using is multilingual. It can hear Chinese. Okay, there we go. The reason it answers in English is the system prompt. Oh, okay. The mouth. Piper is a monolingual per model. You cannot use Lessic model to speak Chinese. It will just sound like gibberish. Yeah, it did. I couldn't understand a single thing. Luckily, I had the like subtitles, whatever up here, right? Otherwise, I was like, I couldn't even understand what it was trying to say. It will sound like gibberish or English accented noise. You need to download a Chinese model. Okay. So let's go and actually do that. Let's download this Chinese model. And now we are going to need to put it into the correct location, right? So I'm going to go ls and I need to go into sound processing. And from here, I want to paste in those 2 commands. And we should get one for Chinese, or we should get 2 things for Chinese. Unable to resolve hosts huggingface.co. That's not fun. Okay. All right, so there's that. And now question number 2 is going to be this. There we go. And who knows what's going on. And yeah, so system prompt first to see if the LLM starts generating Chinese. Your current, yeah. Okay, so we got those 2, and now let's come back up to these 2 things. So the first one that kind of just seems a little bit easier to implement is going to be this push to talk. So maybe we do something like, okay. Did we save everything? So git status here, git add, git commit, trying to change system prompt such that the LLM does not call tools that are not needed, period. Okay, now we are going to start uprooting things. So that's why I wanted to save first. Okay, so on press here. On release. Okay. Now we're going to have helper functions, record audio, all of this. Okay. Okay. And now from within, we're going to do this. And I'm just going to see if this works. All right. Okay, listener.join, and now how do I actually get this user input though? Okay. I think I'm on 3, right? I tried updating my system to be able to use option C, but now I am thinking about how I can actually make it such that it gets the user input, because I don't think I quite understand what's going on. So can you explain what this is doing and how I can fix everything? ? Okay. So now Mistral versus Quinn. All right, this is gonna be the next one. So I don't know, I think it's 4. Can you explain the difference between these two? ? All right. So you have full 8 gigs. Yep. So the U's, this is key, are shared. Okay, you are currently using 6 gigabytes. So the 3.2 is standby. Linux uses it for speed, but we'll give it up. Okay. Free. But because of the cached, you might actually have plenty of room for a 7 billion model. Okay. Your current code, spacebar, in 2 different places, they need to talk to each other. In your current script, on press, on release functions, just print text. They don't actually tell audio recorder to start or stop. Here's the engineering way to bridge them. Okay. Oh, man. We do have to get into threading. Oh, okay. On press, on release, record audio logic here, all of that. Oh, boy. Okay. Failed because Jetson lost internet connection. Okay, so is it just a internet connection thing? Let me just try it again. Okay, so Onyx one. Okay, there we go. So now the non-Onyx one. Or I guess JSON. Okay. So, okay, those 2 and these 2. Okay, cool. So I have that. So now Quinn is from Alibaba, okay? And Mistral is Mistral AI, okay? Exponential, or exceptional and high. Math and logic, okay? This one is high. Superior for Chinese and English. Tool calling, both are very robust. Best for pure C# code help. Best for your Mandarin agent. Okay. My suggestion is go with Quinn 2.5. It is currently one of the highest rated models in its class size. Okay. Okay, so we're doing two things right now. The first one is we are having a problem with let's see. Wait, no. This is the one that I want to be in. We need to get this on release thing working. So then later we can go into trying to figure out the Chinese versus the English. Let's first work on the other one. Okay. Stop recording event. Okay, so we import threading, which we already did, right? No, we did not import threading. Stop recording event. Threading.event. Okay. On press, on release. So key here. Def audio recording logic will not set and then we need to there's a lot of stuff going on right now. There is a lot of stuff going on right now because I also need to do the thing of I guess let's focus on the push to talk implementation first, and then we can work on the Chinese and tool calling problems, period. I guess some of my questions are going to be with this push to talk method, comma, I am still going to need to make sure I keep into consideration which device is enumerated, comma, I also need to figure out which what's the other stuff that I need to do? No. Okay. Audio recording. What you were mentioning in the past regarding that ear to mouth problem that was causing extra transcriptions and taking up so much time, period. Are both of these problems taken care of in the code that you showed me? Question mark. The second thing is I don't really understand what's going on with this code in regards to how we're using multi-threading and how this is actually working. Can we do a deep dive into the code of how it's actually operating? Question mark. Okay. So let's take a look at it. So this is a great moment to pause. Yeah, okay. So yes, the code addresses both, but we still need the get USB index for enumeration, and we will eliminate the ear to mouth delay by streamlining the recording and transcription parameters. Okay. So as of right now, there's a lot of things kind of going on, which is we are trying to smash everything together And when we were building out each individual component, we were at like a 50% understanding of how each thing worked. And we definitely did gloss over some things. And now it's kind of coming back, and we're saying, oh, all right, well, now that we're trying to continue to implement everything together, where are the problems going to be? So the deep dive. How multi-threading works here. So in your previous code, everything happened in a straight line. We got the input, we did the record, we did the transcribe, and speak. Yeah. If the code was busy recording, it couldn't listen for you to let go of the spacebar. That's correct, yeah. It was blind to the keyboard, and that's why we needed that Control-C, yeah. So multi-threading allows the Jetson to do two things at once. Number one, the main thread, the guard, sits and waits specifically for the keyboard listener. The worker thread records and captures audio bits and shoves them into list frames. Okay. The event handshake. So we use event or threading.event, which we've named stop recording event. This is a physical light switch shared between two rooms. Room number one is the keyboard. When you release the spacebar, you flip the switch to on. Okay. The recording loop is constantly checking that switch. As soon as it sees it's on, it breaks the loop, saves the file, and stops. Okay. You mentioned the extra transcription taking up time. This usually happens because of two bottlenecks. So disk I/O saving large 40 kilohertz files and reading it back, and then the conversion running a separate process to downsample the audio. We fix this, or we will set Pi audio rate to 16K immediately. Whisper is optimized for 16K. By recording at the target frequency, we skip the FFM peg step entirely. Okay. So we have this, right? Okay. Recording is false, and now stop recording here. Okay, it's equal to thread, and we need threading. So import threading. Okay. So rate is going to be the 16K here. 16K. Now it's saying channels is 1, but that's going to cause a crash actually. Okay. Record audio worker. So on press, on release, and run interaction. Okay. So this is the main loop here. Yeah, we do this listener.join, okay? And we are going to print processing speech, okay? And then we call the transcribe. But did transcribe change? Oh no, because it's saving to that specific location, right? Yeah, Okay, that kind of makes sense. So let's come down here and let's just do this, right? So what I'm going to do is I am going to come here and kind of just like write all of this myself. Okay. So we're going to come here and we are going to just write this ourselves and try to understand what's going on. So I'm going to have def is record audio worker. Okay. So now this function runs in the background thread. Okay. So audio is equal to pyaudio dot pyaudio. Okay. Stream is going to be equal to this audio dot open. So we're opening up a stream. So format is going to be equal to format. Okay. Channels is equal to channels. Yep. Rate is equal to rate. Input is equal to true. Input device index is equal to input device index, okay? And frames per buffer is equal to chunk. Okay. So we have this, and now print is going to be, I'm just going to copy and paste this because it's fine. Just speak now. Okay. Frames is equal to an empty list, and now we're going to probably append that, right? So while not stop recording event dot is set data is equal to stream dot read chunk frames dot append data here. Okay. Then we clean up and save it, right? Stop stream. Stream.close audio dot terminate. To SSD. Okay. With wave.open. Wave output WB as WF. Okay. WF dot set in channels is channels. Okay. Sample width audio dot get sample size format. Okay. frame rate is rate write frames is doing a byte array, okay, join on frames. And then we print that it was saved to disk. Okay. Okay. So we were able to do that, and then we're going to have this on press and on release, and then we're going to, as listener, okay. So now what I want to do is come in here and actually understand what I was kind of writing here. So, alright, so I guess the first thing is going to be, can we go back over what is actually happening in the audio worker? Question mark. What are we doing when we are actually doing the things such as pyaudio.pyaudio and audio.open? And what is this function actually operating? I'm going to change it to how. How is this function operating? Okay, so that's question number 1. So on press, we have this global recording for both of them on release. So if key.keyboard.space and not recording is true, stop recording event. Hold on, I need some more coffee. I need to take a couple seconds of break to think about this. Okay. So now we are going to have this where we have the global recording, okay? If key is equal to key space and not recording, set this equal to true. Okay, and then what we want to do is stop recording event dot clear. I don't know what that does. Reset the switch to off. The switch, okay, to off, and then start background worker is threading dot thread target is equal to record audio worker. Okay, so we're starting a new thread. Okay. And now on release, so these seem to be like events. They really are events. So recording is false, right? And now what we want to do is not return false yet. We want to stop recording event dot set here, which flip the switch to on. Okay. So listener, dot join. What does listener dot join do? So I can just directly call transcribe here. Is equal to transcribe that, maybe? Once it's released. Okay, so number 2 is I'm now trying to understand how these events and triggers are actually working because I've never really done this within Python. Can you explain how we're doing this and how all of these events occur? Question mark. So just looking at it, right, I'm doing this listener.join. I don't really know what the join does as listener. So I don't even know what this line means. Like, number 3. I see that we are saying with and then a long chain that passes in 2 parameters and aliasing it as something called listener. And then we are saying listen and adding a method or invoking a method, which is called join. But I have no idea what anything is happening within this sentence, period. Okay. So this is probably calling a new thread, like on press, I don't know. And then we get on press, comes in here. I think join means that you wait until the thread ends or something. I have not done much with multi-threading, obviously. So record here. So the recording is a global variable, which we have defined up here, right? So I'm setting this, I'm saying if the key is space, if we hit the space key and we're not currently recording, we set recording is equal to true. Stop recording event. Stop recording event. Where is this? This, okay, it comes from this random. I see that we create this thing called stop recording event, comma, but I don't know how or why we're using it and what the methods are available to me, period. Okay. serial program. Okay. The audio faucet. So you're making a formal request to the Linux kernel to access the hardware. Okay. This initiates the port audio system. Think of it as opening the audio control. This connects the pipe. Okay. Chunk. Since the audio data is a constant flow of electricity turning into numbers, Python can't grab it at once. We have to chunk it. Okay. And now this is the most important part. It's a blocking call. It sits there and waits for the microphone until it's filled up with that many samples. Okay. So the with statement. This line is the manager of your keyboard input. So with keyboard.listener, okay, this is a context manager. It ensures that when you are done, the keyboard listener is cleaned up properly so you don't get stuck in a weird state. Okay, well that What kind of weird state might I get stuck in? Question mark. I need to start charging my device. Hold up. There we go. All right. Okay, the parameters. You are given the listener, the 2 phone numbers, callbacks. Okay, so these are our actual callback functions. If a key is pressed, on press. If a key is released, on release. Okay. So I see that I called it on press and on release, but okay, maybe these are the actual terms. So on press. Okay. So question number 2 is, I see that the keyboard listener has 2 inbuilt parameters that I can pass into the listener. One is on press and the other one is on release, comma. But how does this know specifically that I am asking for the space button? Question mark. It seems like if I press the H letter on my keyboard that this method will also be called. Period. Okay. So .join, this is the anchor. In multi-threading, join means wait here until this thread finishes. The listener thread. Okay. Without this line, Python script would start the listener immediately and move on to the next line of code. The join keeps the script paused until the listener is told to stop. When on release, returns false. Okay, as listener. I guess I still don't understand how this item called listener, which we just use an alias with the with command, turns into an actual thread. So I am coming in here and I am getting this keyboard listener, which is a standard Python library which will listen to my key inputs. I am passing in 2 parameters. One is on press and the other one is on release, and both of those are callback functions. So when I come into my infinite while loop, I will check if my keyboard has a key pressed, and if so, I will call this on press, and the on press is going to come in and start a new thread. then from there, for some reason, my with statement does not immediately come out yet. Or maybe it does come out and gets blocked at the join. So then I now need to invoke this stop recording.set, or maybe it's the return false that causes the join to be satisfied. Who knows? Okay, so this is a signal flag. The stop recording event is the simplest form of communication between two threads. It's a Boolean. .event. Okay, so all things which are threading.event. So this is just saying a Boolean, okay? So this is a threading Boolean, okay? It is thread safe. Okay, why use it? If you just used a regular variable like stop equals false, one thread might change it while the other one is reading it, causing a race condition. Okay. So methods available. So this is just standard methods available to the inbuilt threading event object. Clear, okay, means set it to false. Is set is true, and then set is also true. Is set, it checks if it's true. And then set is set it to be true. Okay, so how they work together. The code is stuck at the join. It's just waiting. Action, you press the space bar. Okay. On press fires. Wait, why does it stop before? Going through your play-by-play, you mentioned that we are stopped at the listener.join before we even press the on press call, and so no thread has even been created at that point, exclamation mark. Okay, so now it calls this event Boolean and clears it, so we're setting a green light, and then starts the worker thread. That makes sense. So thread A, still waiting for you to let go. Okay, the audio worker thread, it enters a while not. So, it's going to continue to check that. Okay. And it keeps filling up the button. On the release, it fires, it sets this to be set high. Then the thread, inside thread B, the while loop checks and sees that it's now set. It breaks out and saves. Okay. Okay, I see. So while here, I'm checking the Boolean and continually doing this. Then once this is set, then I come in here and terminate things, and then I save it. Okay. So I'm going to say here, and then I'm going to say number 5. What do you think of it so far? Question mark. Oops. Oh. Okay. There. Okay. So, what is this weird state that we can get into? The keyboard listener hooks into the operating system keyboard listener hooks into the OS input stream. It essentially tells Ubuntu, before you send a key press to the terminal, let me look at it first. If your program crashes or finishes without closing that hook, which the with block handles automatically, so key ghosting. Your terminal might stop recording or responding to certain keys because the OS thinks that the background process is intercepting them. Zombie threads. The background thread that monitors the keyboard stays alive in RAM even after you quit your script. Resource leak. You might find that you can't start a second instance of your script because the input hook is still locked. So I feel like this is a more broad thing that I need to look into a little bit more. Okay, why does H trigger the recording? Why doesn't H trigger the recording? So you're right, on press is called for every key you hit. However, look at the first line here. Like, I see that, but I guess I'm confused about all of the flow. This is your gatekeeper. If you press H, the function runs, checks if H is the spacebar, it isn't, and immediately exits. Only when the key matches here does the code process start the thread. But then why does it not be the case that I press the H and nothing happens, which means there's no thread which is created, which means that the listener.join terminates because there's no thread. Period. Question mark, actually, but whatever. Threading magic. This is part feels like a paradox. So let's track the instruction pointer where the CPU is currently working. Okay. Your script hits this listener.join. The CPU parks here. It's blocked. It will not move to the next part yet. That makes sense. The hidden thread. Behind the scenes, the keyboard listener has already started its own background thread, silently watching the hardware. Okay. Keyboard.listener has set its own. Let me actually preface this. I have not done too much with multi-threading, but I've done a little bit in the C language. Can we explain these concepts and show me how the Python things we are doing right now might be similar to a C programmer's understanding? Question mark. Okay. So now there's a hidden thread. Okay, has already started its own background thread. It is silently watching the hardware. Okay. You press space, the listener's background thread sees this and executes this callback. Okay. I explicitly call this. Yeah, that makes sense. Main thread is still parked at the join, yeah. Starts, okay. Is waiting for the listener to die. I guess I'm really confused about who is this listener. I'm very much confused about who is this listener. I am still so confused about who exactly this listener is. Period. Is it one of the threads which I am automatically doing, or is it this hidden thread which you have just mentioned, which is created by the keyboard listener itself? Question mark. And if it is the thread which is created by the keyboard listener, can you show me exactly what this thread is actually doing and what is its termination conditions? Question mark. Is satisfied when the main thread wakes up and moves. Okay. Okay, mismatch here. Channels is 2. This one here is going to cause a problem. Since we're skipping this conversion, most USB... okay, I think this is going to cause a problem. I will try it. I think that this is going to cause a problem, comma, but I will see, period. Okay, and we need to disable this. Let's pause it. Okay. Okay. So when I'm at work, almost everything that I do is bare metal, and it is, as it says right there, which is why I started this conversation. Everything is bare metal, and I don't do anything with threading. Now, that's kind of changed recently. I've been put on some kind of really interesting projects, and I'm super excited about that. But most of my experience is just single threaded, essentially like microcontroller code that works with hardware. So I would consider myself more of a, I'm not really a hardware engineer, but I am a hardware engineer. I enjoy software more. I think software is a lot more fun, and that's kind of where I want to go in my career. But as of right now, I am definitely doing a lot more with hardware. And so, like, actually going into schematics, trying to figure out what I2C command do I need to give this specific electrical component such that it actually operates the way that I want it to. That's kind of my job. Um, and so that doesn't require any multi-threading. It's all single-threaded. But I know a little bit about like pthread, and you would do things like pthread create, pthread join, and doing the mutex locks. So I learned a little bit of that in like university, but I never really used it. But I do want to learn it. It's something that I want to investigate. So the gatekeeper. So in C, if you're writing a game loop, you might use something like pull on a file descriptor. Okay. Your on press is essentially a signal handler or a callback. Okay. Even if you press H, the interrupt, the key press, still happens. The OS sends that event to your process. Then this catches it and runs your function. Okay, so the C equivalent would be like this. On press. Okay, so if it's not... So then create the thread. Yeah, okay. It's literally just a syntax thing, so it's not really a... I'm trying to figure out, like, why I even mentioned the C was because C is much more explicit in what you're calling, and there's none of these hidden things usually, unless you're like using a different library. But usually C is a lot more explicit, and so that's why I'm trying to say, okay, well, kind of show it to me in C so that I can see what is actually being called, as opposed to Python, which abstracts a lot of that away. And, oh, I'm just using a third-party library. Okay, great. Or I guess threading would be a standard Python library. Great, but like hidden thread. I don't like hidden things because if they're hidden, I don't know how to use them properly, right? I might be able to get it to work, but if I need to change something, well, then I am kind of in a bad position because I don't intuitively understand it. Okay, so when you write this, Python is calling pthread create. Okay, or the OS equivalent, I don't care. It is calling this pthread create. That's all I'm going to think about. Behind the scenes, the moment the object is initialized, the listener is the thread. Okay. It doesn't wait for a key to start. It immediately... Oh, it's immediate. Okay. What is this listener thread doing? It is running a tight loop similar to a while one that is blocking on a system call to the Linux input device. Okay. It waits for a hardware interrupt, like when I press a key, okay? It gets one, it looks at the key code. It then calls your onPress function on its own thread. Okay. What are its termination condition? The listener thread only dies if one of your callback functions returns false. Oh, okay. You manually call listener.stop or the... Oh, okay. See, now it makes a lot more sense. Now I get it. So now it makes sense why this wouldn't crash or why this wouldn't terminate, because I'm not returning false. I didn't understand that there was actually a hidden function that was, or a hidden thread that was being created in the background. Now it makes a lot more sense. Okay. So let's kind of go through this one more time. All right. Okay. So in my main loop, we do this with keyboard listener, right? And that is similar to pthread create. And we're alive and spinning. All right, so this is now the pthread join on that listener thread. Now it makes perfect sense. And it doesn't exit out of there because it has that thread. Yes. We press H, nothing happens because we didn't return. Okay. You press space here, and we go in and create a new thread for the audio recorder. It stays alive and keeps listening for that Boolean. All right, I release it, and now this signal occurs, and we return false. Then the join hits, and we transcribe it. Okay. Now things are making a lot more sense. But I don't necessarily like this right here. I think that this might not work. Because we are transcribing it, right? So what would happen if... Okay, so I am going to say on press. What happens if I... if I want to check if so should I say if key is equal to dot q, I don't know if this is correct, return false, something like this. I don't think that this is actually correct. Okay. Come here and now do something like this. I'm now thinking about how I will be able to allow the user to quit, because the way that I'm thinking about it now is if I simply have it the way that you suggested, comma, then when the user presses the Q button, then it will just reject them until they press the space, period. So this means they will never be able to actually exit out. Is this correct? Question mark. Okay. Okay, so, and doesn't return false. Yeah. If you press Q, yeah. The ghost transition, the listener never dies, but the very next line, okay. So, now what we need to do is, oh man. Okay. If has attribute key char and key.char is equal to q, okay, fine. Quitting and then should quit is equal to true and then return false. And then okay. In here I should say just if this is and then check it. Okay. Okay, so I'm gonna come up here and say whatever should quit is equal to false. Then within my on press, instead of this, I will have something which says here. So if and then has attribute. Okay, and now we have recording and should quit. So if has attribute key is a char. Oops. And key dot char is equal to q, then print quitting should quit is equal to true, and then return false. Okay. Okay, so then in here I can just say, instead of above here, I can just check if should quit exit or break. Break. And what will that do? Okay, fine. Okay. Let's see. Copy that. Save it. I'm gonna just do git add, git commit. This is my first attempt at changing the chat agent such that the user is able to press the space bar to start recording and release the space bar to stop recording, period. I have not tested this out on hardware and I don't know if it's going to work, comma, I am introducing threading to this project, so there might be more problems that arise, period. Okay. All right, let's push that out there. And let's actually come in here and let's see, we're going to cat into agent. What did I call it? Chat agent? Okay. So cat, but we want to pipe it into here. And V, all of that, and then Control D. And now we want to do Python 3 of chat agent. Okay. Awesome. So this means no module. Okay, so now I need to do, let's see, pip install maybe this. Okay. I'm gonna take a sip of coffee while this is doing its thing. What is going on? I don't know. Anyways, so why this? There are two types of keys, special keys and numeric keys. So it keeps doing this. What is this? Okay. Just keeps spinning. Is this normal? Oh, okay. Well, whatever. Let's try it again. Okay. Raise error. This platform is not supported. X server running the display. What? Okay. All right. Okay. Awesome. So this POIPUT, there are two types of keys. Special keys, which is space and escape. Okay. Alphanumeric keys. The alphanumeric keys are objects that have the char attribute. If you try to compare key equals Q directly, it will fail because key is an object, not a string. Okay. So using key.char is the correct way to catch if the letter is Q. Okay. If you quit the program while audio recording is still running, it might try to write this. Because we use that thread is independent, you can make it daemon safe. There's a lot of stuff going on right now. Let's first just try to get something that works, and then we'll figure out like improving it. Okay, let's figure out how to make it work, and then let's improve it. Okay, so what's going on is you're likely SSHing into your Jetson. Yes, I am. The Linux tries to connect to this graphics engine. By the way, we killed the graphics engine. It's not working because we want to run this unit headless because I am trying to save every single ounce of RAM that I have, and I don't want it to be doing the graphics. Bypass the X server if you tell it to. Use the but requires root privileges. It's finicky. Instead, let's use a library designed for terminal console. So this doesn't care about X servers or displays. It reads the raw standard input. So, okay, so what did I install up here? The pinput. Okay, so now I'm going to do the same thing, but for SSH keyboard. Okay, so pip install SSH keyboard. All right, so while that is doing it, we are going to change this, okay? Does it change anything we have in here? So instead of this PM put, let me come here, import keyboard. Okay, so where am I using keyboard? All right, so keyboard there, and keyboard there. Great. Okay, so I am going to hashtag you out and paste you in there. Okay. Awesome. So SSH keyboard. Now I need to change these things. Okay. So listen keyboard. So I come in here and instead of this, I do listen keyboard here. Okay. On press is equal to press. Then on release is equal to just release, and then release. Okay, and then sequential is equal to false. Okay. Now I need this press. And release here. Okay, can I just copy and paste these? So I think I'm just going to copy and paste them and then figure out what I need to do to get them to work. Okay, so now copy and paste you, and I need to shift everything over. Okay. Okay, now is that good? Yeah, and now I need to also have this, whatever, should quit, right? Should quit, because we're capturing this and this here. Run interactive cycle. Jeez. Okay, so SSH keyboard, but we define that up here, and it's right because we just don't have that installed on our device. That's fine. So I'm gonna come in here, I'm gonna come, and we just installed it on our actual device, but now we should be able to do this and paste it in there, right? Hello, I'm trying to see if you are able to actually hear me. So what do you think?
I'm so sorry to hear that you're feeling tired today. While I don't feel emotions like humans do, I can certainly understand and acknowledge your fatigue. It sounds like you need a good night's rest. Sometimes all we want is to snuggle up in bed and let our bodies recover. Don't worry, it's totally normal to feel this way. By the way, it seems like I'm currently surrounded by bright lights. You mentioned that all lights are currently on in your knowledge base. That must make it even harder for you to wind down. Would you like some suggestions on how to create a cozy sleep environment?
Okay. That obviously was not what I was hoping for. Copy this and paste that into there. I can quit out of this. And I can also do cat and then here, right? And just paste this in so that it knows what's going on. All right. Oh, this is starting to get a little bit long. Wow, okay. It's really getting long. So paste that into there and say, it didn't really work because when I pressed the space, I noticed that my input on my terminal was going space, 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 space. The model did start talking to me, but it was talking about being tired, which is not what I mentioned at all, period. Okay. All right, let me get some more. Swap out my coffee. Done with this one? Time for round 2. All right. So, invalid sample rate here. Well, Whisper loves this mini USB. Yeah, so it's unhappy about that. So yeah, I was thinking that this was gonna change these back to the safe ones. The space. Okay. When you use this, your terminal is still trying to echo your typing screen because you're holding the space bar. The terminal thinks that you are just typing this. Turn off terminal exit. Okay, try. Okay. Yeah, we can do that. That's fine. Here. Let me do this here, right? It's not happy, although is deprecated. Whatever, that's fine. And then set a finally block down below. I need to wrap this entire thing in a try. Okay. Get you out. Now, make sure that this is on the right as the try. Yep. And finally, I don't think that's the right one, but whatever. Finally, and now os.system, okay, and now echo, okay, so yeah, whatever. I think it has to do with these things, unfortunately, which is going to cause a ton more problems. And I thought we were able to get it working with the 48. Wasn't it working previously with 48? What if I just did that back to 2? Okay. Okay, come here and try this again. Okay. Control D. So I'm wondering if you are able to hear me or if you're not able to hear me. Just, I guess, tell me about your day.
I'm so sorry to hear that you're feeling tired and sleepy today. As a friendly AI companion, I don't feel emotions like you.
Okay. All right, well. So, there's this, right? What was the error that it was giving? Invalid sample rate. But now I'm a little bit confused because I thought previously it was actually working with this 16,000 rate, but I can't quite remember. Period. Okay. Because we were doing this. Okay. Okay. Yeah, so like right now the problem really is the interaction between the hardware, the hardwares, because we have multiple hardwares. We have this one, we have the actual Jetson, which I'm not going to pick up right now just because I don't want static discharge, but the showed it at the beginning of the video, right? The Nano. And how do you get those to actually communicate with each other? The exception is here in your logs because that thread crashed before it could record anything. The disk was holding the audio from the very first oh, right, that's why, because it's getting that. That actually makes a lot of sense. Due to a sampling rate. Okay. Record the... Damn, now we need to go in and, actually, we still need to do that. To fix this like a C programmer, we can drop the C now. We can drop the C. Handle the mismatch ourselves. We will record. Isn't it the case that you told me that doing this downsampling is actually a really inefficient way of doing things because it's going to add a lot of overhead and timing issues? Question mark. Here's my current code, period. Downsampling, if your hardware can avoid it. Okay, the frustrating reality of system programming is we have a conflict between software idealism and hardware reality. Only supports those. Okay, yep. The goal, record at 16K so Whisper can read the file instantaneously. The obstacle, this OS error, invalid sample rate, provides your USB microphone proves your USB microphone physically cannot spin down to 16K. That makes sense. Inefficient but working. Record at the 44, and then it's gonna add half a second of delay. Fine, whatever. So we need to do that. So now what we can do is we need to go back and do the sampling. Darn. Okay, so now this one, what was it? It needs to be the 44.1, is that right? Instead of 16K, we need 44 one. And I think that we need the 2 channels, right? And now in my transcribe, I need to have this. And I still do it though, actually. I still do the transcription. So actually it might work. Now, if I just change that one line of code, OS.remove, I don't need to remove it. I actually don't think it was recording. One final check is to do that. Okay. So I am going to cat this and paste it in and do that, and then do this command here, paste that there, and what does this show? If you see a list, or if you see a device listed as mic is ready, okay, I don't know what that's supposed to do. It's fine. Hey, so I'm talking right now. I was wondering if you can hear me. I have not let up on the spacebar yet, and I'm still holding it, but
I'm so sorry to hear that you're feeling extremely tired today. I may not feel emotion.
Okay. Alright, so let's do this here. Let's come up to here and do this entire thing, and then say what I experienced. Alright, so as we know, this is starting to get kind of long. Alright, okay. Copy you, paste the entire thing into here, and then say, I observed that when I started pressing the space button, I was talking, and then I got the error, which was that one that you see in the output. Then I continued to hold the space button the entire duration of the time, and then my model started trying to invoke a tool and started responding to me. The entire time I was still talking and had not let up from the space button. Period. Okay. Alright, so yeah, you press space and this started at the 44. Rejected it. Okay, the escape because your background crashed immediately while never ran. Okay. So the main loop continues. Because the background thread crashed immediately, the while set never ran, the main loop continues even though you were still holding space. Non-blocking in certain configurations because the thread finished by crash. The main loop assumed that the recording was done. Okay. So we know why it was talking about tired. That's not a thing. Most budget or embedded microphones are extremely picky. They often only support this 48. Okay. Yeah, I think it was an even number. How do I determine that? I remember that there were some Linux commands which I was able to do in the past that communicated to my microphone speaker device that I was able to determine all of these conditions, such as the number of channels and the frequency and everything else, period. The microphone speaker which I am using is definitely a budget one. It is a Punk Wolf USB PC speaker. It is a combined speaker and microphone, period. Okay. So I'm going to do that. I think it was 48. A record and the proc. Okay. Let's come in here and do that. So a record and yeah, here it is. 48. Okay. The proc and the proc file system. Since you're on Jetson, you can query it. Okay, so a record here. Let's check this. See what it does. Whoa. Hello. Hi. Oh, that's really cool. Okay, so anyways, Control C. Wow, that's really cool. Okay. Obviously, it is not like actual hexadecimal things, or not like readable things, but it was changing every time I was talking, so that's really cool. So let's do this command again, a record. Okay. So a record. So we're going to get a whole bunch of things. So help, list devices, okay, device name. Okay. Do we see something that says like channels? IMMAP, rate. So can I do like a record and then can I chain these, right? Like can I do D and C? I'm just curious if I can do this, and let's just see if I can do that. So, okay, fine. Let's just do D, right? Okay. H. Select a PCM by name. So that's the argument that I need. What if I just did the C, right? Interesting. Okay, so I don't know. So we're gonna come here and we're just gonna do this and copy this, and we can paste that into there. Now, specifically at formats, channels, rate, kernel perspective. So now let's cat this, right? Let's come here, cat this a sound. Okay, so now I'm gonna come in here, copy this over, and alright, that's pretty cool. So it's failing here. I think we need 2 channels. Can you go over everything that I showed you in these commands and tell me what it means and how I can use this information? Question mark. All right. So let's I'm gonna move that so that the sun is not on my thing. So I think that we need channels is 2, and I think that we need the sample is 48, like that. Okay. So, under capture section, the microphone. The chip lists only 48. It does not support this here. So, and it definitely does not support the 16. So that's why we're getting that. Channels too. Even though it's a small microphone, the chip is hardwired to send a stereo. Okay, so this here matches that, which, okay, great. Full speed. Okay, so how to use this in your code. Exactly. Yep, that's exactly what I was thinking. So I'm going to be removing this because I was correct. Goodbye. All right, so, oops. So now I'm going to come here. I'm going to copy all of this. I am going to do my cat into chat agent here. I am going to paste it. Okay, and then I am going to Python 3 chat agent. All right, can you tell me if you are hearing what I'm saying? And yeah, so I'm just going to keep on talking, but apparently you have exited
It seems
immediately.
like you're giving me some important context about your current situation. So,
All right, so it did something different, but not quite exactly what I was hoping. Okay, so now let's come here. Oh my goodness. I'm not gonna copy and paste that entire thing. I will just do it from here. So come here, and then I'm gonna copy all of you and say, here is my current code. Okay. Paste you, and now come down here. So now I am experiencing a different thing, which is I will press my space bar and start talking, and at about a quarter of a second later, I see that it says saved to disk and immediately starts responding to what I said, but I never let up on the space bar. So now it seems like it is actually being able to communicate with the device, and I'm not getting in to any errors, but it doesn't seem to be continuing to listen the entire duration, period. All right. So let's actually git add here, git commit -m, and say, I was running into a lot of issues where the speech which I was generating was not being successfully picked up by the microphone. I needed to change around system parameters and change the way that I was taking in the data, period. Currently, I am able to start recording audio input, but my program immediately stops listening to my voice and does not wait for me to finish talking by lifting up on the space bar on my keyboard, period. So it immediately recognizes that I pressed the space bar and immediately returns without waiting for the on release of the space bar, period. Okay. So we will get that, and you will stop that, and I will go like this, and we will do that. Okay. Awesome. So now, here we go. The bad news is you've run into this. Oh, great. Especially over SSH, the OS doesn't like to send the down. Oh, great. It sends down, 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 down very rapidly. Oh, great. Why it's I took its end the Sigalinti. 现在我知道为什么这个问题要出来，但是 okay, yep, your OS sees that you're still holding the down key. Okay, interprets these repeat signals as press new events. As soon as it thinks that the key was released, okay, debounce and synchronization. We'll need to do two things, and the until parameter to lock the main thread until the key is physically released. Oh my goodness. I should have just done a single press and then a single press again. We will add a check to see if we are already recording. If we are, we ignore any additional downs. Okay. But does it do a... I don't think it will do the on release anymore, right? So hold the space bar. Okay. Until space. Okay. Okay. And I want to come in here and import stop listening. Okay. What is stop listening now? So we're gonna... So if they press it, okay, and then return. Oh, if... Oh, okay, so this is the queue thing. Okay, fine. If the space, if not recording, okay, only start if we aren't already busy. And then daemon true, okay. No, not on press. We would just want press now. Okay. Key is equal to space. If not recording and not recording, okay. We set this equal to true. Stop recording dot clear. Threading. So we do the same thing, and then, so the only thing that's different is this daemon equals true? Until space. Okay. To make sure your thread doesn't hang or crash if the hardware is busy, let's wrap up the read in a small... Hold to talk logic. It essentially turns the keyboard listener into a synchronous wait. Okay. So I guess I'll just try adding that daemon equals true here. So we have the target and then daemon is equal to true. Okay. And now from within here, I want to change this, right? And I'm gonna have, oh, where'd it go? Here on release. Now instead of sequential, I'm gonna say until is equal to, no, under, until is equal to space. Okay. I have no idea if this is gonna work. I really have no idea. Okay. Can you tell me your name and what are your favorite hobbies? My name is Timothy Grant.
Oh, it seems like you're providing me with some information from your knowledge base.
Didn't work.
You've let me know that all...
Didn't work. Didn't work. Okay. It still did not work. It immediately went to return before I lifted up my key spacebar, period. Okay, from release, only use the Q logic. Add a debug. Then do stop listening. Why was it happening? So when you have this thing, when the until space, the listen keyboard function is looking for, if your release function calls stop listening, you are essentially hanging up the phone. Okay. So on release, I need to stop? What? On release, here, recording is false. Okay, and then I set this. And then do not call stop listening here. Okay, fine. And do I need to actually have that import statement that I just deleted? Hold on a second. Do I need to have this like at the top? Import stop listening. I think I would, right? Okay, so on release, actually I want this one, right? This is on press, and I don't need this anymore because that is hideous to do an import statement right there. Okay, so I still want this, but on release, I do not want this one. And actually, I think I should get rid of these here. On press and... because we're not doing this anymore. So this is just going to like trip me up. Okay. So there we go. Okay. Copy you. We are getting really good at this, huh? In here and paste you into there and get out of there and do the Python. All right, can you tell me about an interesting story about a bear who's looking for honey? I am still holding the space bar, but I see that it stopped.
Hello there. I see you've shared some new information with me. Just to confirm, you're saying that all lights in your environment...
All right, that is awful. That is unfortunate. That is so sad. I am still having all of these issues with it. 这个好不容易，为什么你没有用的？快点儿！ Ah, and I forgot to even give it the context of what was going on. I see what's happening in your latest code. This is because a subtle behavior. I hate this SSH keyboard. I really hate this. Is looking for a clean single release event. However, because this is auto repeat turn on, your keyboard is sending dozen of press events. So you can see the gate working in your terminal. You know what? Old. Release old. Okay? I don't even care at this point. Just let's try it. Copy you. Okay? Now I am going to go and do this. Whatever here. Paste you in. Okay. Hi, so I was wondering if you could tell me a story about a bear who is looking for honey. He's really...
It looks like you shared some temperature data with me. The current temperature is a lovely 20 degrees Celsius.
I was asking it to tell me a story about a bear who's looking for honey, but it still is not able to do it! Exclamation mark. I don't like that. I hate this SSH keyboard. It's terrible. It is terrible. Okay. It's like flooding the buffer. We'll move all logic into press. One tap starts it, the next tap stops it. Okay. I'm just gonna go like this. Git add here, right? Git commit. I am attempting to get my program to wait the entire duration that I keep my spacebar pressed, comma, but the problem is because I am running this software on a headless device, which I am SSH'd into, comma, when I hold my spacebar on my MacBook, comma, I am actually just sending multiple down commands over SSH, and it's not actually getting the real press and release, period. So now I'm trying to find other methods of keeping the Python code listening while I am talking and have my spacebar held, period. Currently, this method is not working, period. Okay. Alright, so now I'm just going to come in here and get rid of this. So I'm going to, oops, release, and we're going to, right, all of you, yep, goodbye. Paste you. Okay. Copy all of you and come here. All right. So I was wondering if you could tell me a story about a bear who's looking for honey, and I see that you are already not able to do it.
It seems like you shared some no's.
Okay, that is, this isn't working. This is not working. Okay. this is really not working, exclamation mark. I'm thinking that we have to change up our method. Okay, why it's failing. Tap the space bar. Okay. Remove the gates. So on release here. Okay. Add this line. Verify the recording. Okay, fine. I'm gonna do this. If you make that one word change, removing here, the script will finally... Okay, let's just try it. Let's try it. User input right below here. We're going to come here and we're going to say this, right? And I'm just going to remove this, right? It's fine. And now it wants me to remove this, okay? But we added this because we needed it, apparently. But now we don't need it anymore because I don't know why. I don't think this is going to work. But I'm going to try it one more time. If it doesn't work, I'm going to say let's try a different method. So let's see. Did I do that correctly? Because I feel like I hit another button. Oh, whatever. Hi, so I'm wondering if you are able to tell me a story about a bear who is listening and...
It sounds like we've got some important info.
Okay. Right now, this is just garbage. This really is garbage. Okay. I just want to do a different method. Blank audio, yeah. So I'm going to do this, and I'm probably going to say, like, let's just do a different method. Good news? Why is this good news? Just trying to open the device at here. Channel mismatch. Okay. No, this is... This is not working at all. Okay. This is still not working because when it says speak now, it immediately goes to the recording stopped and it doesn't wait for my key to come back up. I think that we need a different method for performing this. I really don't think that our current method is working, period. What would you suggest? Question mark. It needs to be something that will be capable of running on a headless device where I am sending my keystroke commands through SSH, period. Maybe we could even have something where I do one press on the spacebar to start and another on either the spacebar again or even on a different command, such as the M button to stop the recording, period. Okay. Okay, so the toggle method is definitely the most... Okay, so we're going to come here and we are going to say if it's equal to space, recording is true. We're going to do all of this, right? Okay, and now if it's equal to enter, then we stop. Okay, so inside of my main loop here, I am going to try to do this. I have this keyboard listener, okay. And then okay. So now I'm going to come here and delete those ridiculous ones, right? This also did not work. This method of debalancing my space bar to allow the user to continue talking until they release the space bar did not work, period. Okay. All right, so now essentially I'm just gonna, I really don't, I'm getting a little bit tired right now. I just want to get it to work. Like, please just work. Why are we passing on this? If it's quit, then we quit. Okay. If it's space, if it's enter. Okay. Let's investigate this and let's delete this. Let's delete all of this. Okay. And we're going to come in here and paste this in here, right? And I'm going to get rid of you because we already have it up here, right? So we already have that, so we don't need that. And this means that we are going to have our space bar. It comes in here. It does this stop recording event is clear, so it sets it to false. Okay. And then we start a new thread. Okay. And then we will keep listening. Okay. And we wait until enter is pressed. And that keyboard listener, wherever it is, right? Listen keyboard is going to see if we hit the enter. If we hit the enter and we're already recording, we're going to set the recording to false. We're going to set this event to true, which stops the thread, the other thread, that background thread, and then we stop listening. Okay. And nothing happens on release. Okay. How are we feeling about this? I don't know. Hello, so I am trying to hear a story about a bear who is looking for something to eat, and he's really hungry for some honey. And he sees a hive up in the tree. Now, how does he actually get that? Ah, okay. Now we called the tool incorrectly, but that's okay. We're not worried about that.
I'm so happy to help you with your story. It sounds like an exciting adventure for our bear friend. Okay, let's think a bear wants honey from a hive
it's
in a tree.
working.
Here's a possible solution. The bear could climb the tree using his strong arms and claws. Once he reaches the hive, he he might try to figure out how to get the honey without hurting the bees inside. Maybe he'll use some sticks or leaves to gently knock open the hive or find a weak spot in the tree trunk that allows him access. But wait, you mentioned all lights are currently on. That's not really
Yeah.
relevant to our bear's adventure.
You're right, it's
but I have
not.
to say it made me chuckle. Now, let's focus on getting our bear some honey. What do you think? Do you want to add any other challenges or obstacles for your bear friend to overcome?
What if it's raining outside, and how would that affect the story? Hey. Get the status of lights again. But anyways, that's fine. It's thinking. It's thinking.
Now we're getting into the rain. If it's raining outside, our bear's adventure just got a bit more challenging. With all the lights being on, thank you for clarifying that. I imagine the rain would make the tree trunks slippery and hard to climb. The hive might also be harder to reach due to the dripping water and fallen leaves. In this scenario, your bear friend might need to come up with an even more creative plan to get the honey without getting himself soaked or hurt. Here are a few possibilities.
Okay.
Asterisk, he could wait until the rain slows down or stops altogether, and then make his move. Asterisk, he might use some makeshift tools or materials he finds in the forest to create a bridge or ramp between the tree trunk and the hive. Asterisk, if the rain is really heavy, our bear might need to find an alternative way to get honey, like searching for another beehive that's dry and accessible. What do you think? Do any of these ideas inspire your story, or do you have something else in mind? By the way, I'm loving this collaboration. Feel free to share as much or as little information as you'd like about your story, and I'll do my best to help you out.
All right, there we go. Okay, so now I'm going to try the cue. Let's see if it works. It did. Okay. Okay, so awesome. That is amazing. We got it to work. Now, obviously, it is invoking the wrong tool, but we said that we were going to fix that later, and now has become later. So let's copy and paste this into there and say thank you. So I am going to paste you into here and say thank you so much for all of your help. It seems to be working now. Okay, there we go. Now, what I want to do is commit. Okay, so git add git commit -m. The Python is now, no, the chat agent. Okay, what do I call it? Chat agent 1.py is now fully working, and I am able to press the space bar as the signal to start voice capture, comma, then I am able to press the enter button to signal that I am done speaking, period. The agent is able to take my voice, transcribe it into words, comma, send that prompt to the LLM, comma, attempt to determine if a tool is required, comma, invoke that tool if the determination was that a tool is required, comma, then respond back to the user, comma, take that text which the LLM created to give to the user, comma, then transcribe that text into sound and send it through a voice to the speaker, period. The user is now able to have a dynamic conversation with the agent, period. All right, let's git push origin main. Okay. So here we go. It's hilarious that the AI is trying so hard to integrate the light status. Yeah, we need to change that now. I guess first off, we should clean some things up. So we don't need this anymore, right? So let's get rid of this, okay? And now we can get rid of all of this stuff as well. Okay, I don't need this anymore, right? We're good with that. Do I need this on release function even? I'm not sure. Okay, I don't know if we even need that system thing anymore. So this happens because the LLM is being too helpful. Yeah. So a couple of Victory Lap tips for your Jetson. So if you want the AI to stop talking about the lights unless you specifically ask them, it needs to be stricter. Audio buffer. If you notice at the beginning of your sentence getting cut off, you can add a little sleep right before the while loop to give the hardware a tiny head start. Okay. Okay. Oh, the other thing that I just realized is I was able to say about the weather, right, that it rained, and it continued from the previous message about the bear. It knew the context. And now, obviously, we've done that we append our messages, right? And so the messages have the history, which means that it's working. So we did all of that orchestration. So that's actually a huge win, and I didn't notice it until just now. Okay, all right. So what else? I mean, there's a lot that we want to do now. Okay, so I don't even think that I need this anymore, right? I don't need that. Oh, audio recording. Hold on. Never mind. I guess I do. Pi audio. So this is whisper, which I do need. Okay, fine. Oh, is that pi whatever it was? That weird thing. The piper? No, not piper. What was it? I forget what we were even calling it. Okay. So now, what do I want to do? I kind of want to try to add the Chinese, right? So should we try to add the Chinese, or maybe we try a different model? I guess now we can try to update the specific, I'm just going to use this, specific LLM local model which I am using, period. Can you compare and contrast many different models which you think might work on my system and be beneficial? Question mark. All right. So I'm gonna unplug this because we are done charging. Have full battery. All right. So 2.5 coder. We don't want coding logic. Yeah, we do not want coding logic, actually. So this is what I have. I have the 3 billion parameter Llama 3.2 speed and efficiency, the Goldilocks model for the ORN, okay, while maintaining solid reasoning. Okay, So it's not very good, actually. It's not good at reasoning. So let me come... does it not... come on. Oh my goodness. Okay. All right. Where is the scroll bar? Where is this? This is... Okay, that was fun and obnoxious. And it still didn't even do anything. I was hoping that it... No, please do not go to a different... Okay, so Llama 3, so 12 billion. This is Mistral, a joint project by NVIDIA and Mistral, but for 8 gigabytes offers a... It's a tight fit, but offers a context window and superior tool calling capability. Interesting. Okay. Best for okay, speed and efficiency, math and reasoning, deep context, multimodal vision. Okay, no. For your .NET Python development, it's great for raw speed here. So specifically what I'm looking for in this project is I want to have my NVIDIA Nano be a chat agent, which I am able to talk to, and it will be able to also have access to certain tools such as the temperature or the status of the lights. And so it doesn't need anything to do with logic of coding, because all of the code will be written within the tools, and I will write that code to just do whatever needs to be done, and the tool will just return back the answer back to the model, period. So I just need something which is good for talking, but very accurate for determining if a tool is or is not necessary, period. That's one of the biggest problems that I'm coming into right now, is it's trying to call tools which it doesn't even need, period. So can you tell me what models would be good for this use case, period? I'm also not extremely concerned about speed, because it seems to be pretty good right now, period. Okay. Okay. Intent classification, deciding whether to pull the trigger on a tool or just keep chatting. You need a model with high instruction adherence. Okay. On the Jetson Orin, some models are chatty and just try to be helpful by hallucinating tools. Okay, so this I'm a little bit concerned about it because it only has 3.8 billion parameters. The Logic Specialist is currently the pound-for-pound king of reasoning for small models. It fits, or why it fits. Hold up. I'm gonna take another sip of coffee and... Okay. So, why it fits. It was trained on a... It was trained with a heavy focus on logic and multi-step reasoning. It's much less likely to accidentally call a tool compared to Llama. It is very stiff with instructions. If you tell it only use a tool if the user explicitly asks for a status, it actually listens. Okay, so we would do like ollama run and then phi 4. Now, I actually can try a whole bunch of different models, and the reason for that is because I am constrained on RAM. I am not constrained on SSD. So I could try running the Phi, and then I could try running the Mistral, and then I could try running the Qwen, right? Because I can download all of these models to my SSD, And each time I'm only putting one of these models in my RAM at a time. Okay, so let's go through and kind of look more at this. Mistral is one of the first models to natively support function calling in its architecture. If it's one of the first, it's probably the worst, right? If it's the first, that means that other models have come out which built on top of Mistral. Although, actually, maybe if they've created new models, that means that they're the industry leader, and now I'm using their new model. Okay, never mind. Tool calling or function calling in its architecture, why it fits. Version 0.3 specifically improved the tool use token to understand the difference between the user saying it's dark in here and turn on the light commands. Okay, it's a very balanced personality. It feels like a friendly AI but maintains a professional barrier regarding tool execution. So, okay. Let's actually, while we're doing this, let's actually go and download these models. So let's download all of them. So Ollama, okay, run. Would it be run? I don't think we actually want run. We want to just pull it, right? But if we run it, it does pull the manifest. So whatever. We'll just do that. And it will do its little thing. Okay. I am seeing, hold on, I'm seeing 9 gigabytes. Okay. Why am I seeing that this Phi 4 is actually 9 gigabytes, question mark? I think I need to actually specify the parameters. I think I need to say the 3 point. Okay. I think I'm going to try all 3 of the models which you suggested, comma. What is the command to actually just get the models onto my SSD? Question mark. And if I accidentally did the wrong command for the Phi 4, how do I get rid of that specific manifest which I have already pulled down and put onto my system? Question mark. Okay. So it's very stiff. All right. This one is, we're just going to do this, but we're going to figure out what the correct command is first. System prompt. Okay, so while you're using it for coding, while you aren't using it for coding, Quinn training on structured data makes it incredibly precise at following system prompt constraints. So it's excellent at negotiation. If you say, do not call the light tool if the user is talking about a bear, Quinn is statistically more likely to respect the boundary than Llama 3.2. So I'm just saying that Llama 3.2 is pretty awful. The other thing that I'm noticing is I keep checking to make sure that I'm still recording, because whenever like I do these longer videos, I will run or keep going, and then if I run out of memory on my MacBook, it just like stops. The video just stops. So yeah, anyways, if that is the case, the video will just abruptly end. So if you see that happening, then that's what happened, is that the video just stopped because I ran out of memory. So it could happen at any time. I don't know when it will happen, but we'll figure that out. I don't want to just keep talking into the ether though. All right, so the benefit, high intelligence to size ratio. I do like that it has 7 billion parameters. I want to be using as much of my RAM as I can, right? It feels much like a larger model like GPT-4 in terms of how it parses your intent. Okay, so chattiness is, if it's low, I don't really want it because I want this to be a friendly chatbot. So far, what I'm seeing is Mistral. So Llama 3, this one is terrible. It's really bad at tool calling. So what it seems like is these two. So Quinn and Mistral seem to be the best ones. Okay. It doesn't, since you mentioned the model is calling tools, it doesn't need the model change. Hold on. The model is calling tools it doesn't need. The model change will help, but you can also harden your tool determiner prompt. I've been trying to do that as much as possible. Try adding a none. Okay. All right, and now, can you give me some suggestions about how I can start making this into a bilingual application where I can speak to it in both English and Chinese? Question mark. All right, so I'm going to do this. I'm going to press enter and it will go about its thing, and we are still doing this. So the 14 billion parameter, yeah, that's not going to be great. The 14, that's why I said I think we need to specify the number of parameters. The 14 billion is roughly 9 gigs, which is outside of our RAM, so we wouldn't even be able to fit it within the RAM. While it's incredibly smart, it would likely be too heavy for the 8 gigs. Yeah, the 9 is bigger than 8, so. Okay, so the default. Ollama currently points to the 14 billion parameter since your system only has 8 gigabytes of unified memory. Attempting to load the 9 gigabyte model will cause it to spill over into the swap memory, which is not what we want. So I can do, once this finishes, actually I think I can just like stop it. Okay, so I should be able to do Ollama, was it list? Let me just try help. I think it's list. Or PS. No, PS is running models. I don't want PS. List, yeah. List. So RM and then all right. Well, okay. I attempted to exit out of this command, but I don't know where it's actually stored, and I don't want this taking up hidden memory within my SSD, period. Okay. So now what I can do is to download the correct, use pull. Okay, so I can do, I actually don't even know if I want this one. I mean, we can try it. Why not? Ollama pull and then phi4 of mini. Okay. Does not exist. Awesome. So now Ollama pull Quinn 2.5, and we have the 7 billion parameter, although no, we don't. We have this 8 billion parameter one right there. It's 4 gigs. Okay, whatever. Let's see if that, okay, so this one seems to actually be there. This one's 4 gigs. Okay, fine. So then we can try this one here. So now making it bilingual. This is an excellent evolution. All right, let me this was number 1. Let's do number 2 is going to be here. And we're just going to say this right there. Okay. Number 3. So we'll need to remember to do this one. Okay, so making it bilingual. You'll need to update 3 specific areas. Text to speech. Whisper is set up. It's already multilingual. And we kind of realized that when we were speaking to it in Chinese, and it already understood what we were trying to say. You need to ensure that you are using a non-English mode. Okay. So I think we already are using a non-English mode. The brain. Qwen 2.5, which we're downloading right now, is our best bet. It's developed by Alibaba and is arguably the strongest open source model for English and Chinese bilingual tasks. It handles code and logic. Okay. Piper is fast, but each Onyx file uses a specific language. To make it the agent speak back in Chinese, I need to download this, which we did, and then update speak function to choose the best model. Okay. So, while this is doing its thing, I'm going to go and use the restroom and then come right back. So, hold up a second. I will be right back. All right. So, it is still at 62, and make sure that we are still recording, which we are. Okay, so now we have our speak, and what we're going to say is, why would I do this? Oh, okay, so this is Chinese characters are between these ranges. And so if there is one within our text, we are going to use the Chinese model. Okay, got it. Awesome, 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 awesome. So now let's go into speak, right? And let's where's speak here? Okay, so what I'm gonna do is run, okay. Model is equal to here, otherwise not. And if I do this, it's gonna mess everything up, but that's fine because I kind of need it to. Oh my gosh. Okay. Control A, copy U, and then just refresh because this is ridiculous. Okay. There we go. Kaideng. Okay, so speak here is, I'm gonna say, all right, so I'm gonna come here and I'm gonna say if any for what? U for E00. What is this right here actually? So within our any command, there is this. But what does that actually mean? Okay, and I see that this has just finished, so we're going to pull the next one. We're going to do Ollama pull and Mistral 7 billion V 0.3. Okay, hopefully that does not exist either. 7 billion. Did I misspell it? I don't think so. Okay, whatever. We'll copy you and put you on the same thing up here. Okay. So does not exist, and then down here, same thing, that does not exist. Okay. What does that mean? All right, make it bilingual here. Brain, got it. Okay, so let's keep going here. So if it contains a Chinese character greater than or equal to char, so each char is, if anything is between these, like, what would it be? Like ASCII format, I guess. U9FFF, okay, for char in text. So if any of these, then model is equal to this one right here. Okay, else model is equal to this one, but then how are we actually how are we using this? Okay, I don't think that this is correct. Number 4, does this, why am I typing it? Does this look correct? Question mark. How are we actually using the model? And if you notice, I am having my models as absolute paths, period. So I'm going to paste that. I'm also, oh, whoops, I forgot to do the speak part. Okay. So I'm going to come up here and do the speak right there, and then before that I need to have this here, and I'll say like paste that into there, right? And both of those are for the English, but I now have, so I can do ls inside of my sound processing, right here, and so on my Jetson, this. Okay. All right, so there we go. While that's doing its thing, make sure I'm still recording and take a sip of coffee. Cleaning up the... Alright, it doesn't always show up in the list because the manifest hasn't finished, but the blob stays in a temporary folder. Okay, stores everything in these models. Is smart enough to prune orphan data, run this command to clear out... Okay, so like garbage collector or something. Whatever. I think it will run when I reboot my system, but let's just try it. Ollama garbage collector. Okay. So no. But anyways, that's fine. Alright, so are likely because the exact tags are slightly different. So this should work as is, which it did. Notice the V. Okay, so let's try this. Mistral. Let's just do it here. Pulling manifest. Okay. So what was it angry about? I just did V 3.0. I didn't specify the 7 billion. Okay. But it looks like it is in the correct or like size. Okay, and then we'll do this one. This is going to be our next one. Okay. Then we can try all of this. So the /U followed by numbers is a Unicode escape sequence. What is Unicode escape sequence? Okay. Computers only understand numbers. Unicode assigns unique number, a code point, to every character in the language. So this 4E00, so hexadecimal number right there, is a hex code for the first common character in the Chinese block. And then the U9 FFF is the end of that block. Okay, so of the Chinese alphabet. Yeah, I mean, that makes sense. I just don't know exactly what this okay. Can we go into more detail about what a Unicode escape sequence actually is? Question mark. I feel like this is an important concept to know as a software engineer, comma, but I don't know about it yet, period. So just tell me about the actual concept and give me some examples of when I can use it, period. All right. Your logic is mostly correct, but there's a typo here and hard-coded string. Okay, so oh, okay. So where's my speak? Speak. Did I do a double U? Yes, I did. Double U. Okay. Anyways, that was stupid. That was stupid. W. Okay. The other thing is I noticed there's like this giant gap. I want to get rid of that. Where was the giant gap? Here. Okay. All right. So now in my speak, we're still here, pathing. In your command string, you are still using model path piper, the absolute path to the English model, instead of model variable you just calculated. Yes, that's true. Since ONNX files are in system processing, make sure your model includes that. Okay. Yeah, so this makes a lot more sense. And then we do selected model. Correct. Okay. And I'm going to say selected. I'm going to do it like this. Like selected Piper model. Okay. Now selected Piper model here. And we're going to go into, copy and paste this into here, right? Like that. And same thing for this one. We're going to go into here and copy you. And you're going to get in here. Okay. And now, instead of model, we're going to do selected Piper model. Okay. Okay. Selected Piper model. Awesome. Now it makes sense. So, yeah, this one is at 100%. And I already lost my thing of what we were going to copy and paste. So let me get that again. Come in here, and what is it saying? Verifying everything is successful. We're going to paste this. This is the phi one, right? Hopefully this will work. Does not exist. Okay. Once again, we're going to do this as follow-up number 2. Actually, let me just do this entire thing so that it shows that the first one did work. Okay. All right. So now the other thing that I'm thinking about is I will actually need to... I actually don't know if I need this anymore. Maybe I do, but okay, whatever. I think I do because I need to still get to the executable. But I now want to be able to make sure that it responds in Chinese. So this is just the talking, but I don't know if the model is going to respond to me in Chinese. Okay. So I will need to come in here and actually see what did I say, what did it capture, and then from that I need to determine, like, okay, if I'm speaking in Chinese, then I might need to change my system prompt to a Chinese system prompt and then send that to the LLM and then have the LLM respond back to me. So, but let's even see, where is the model, right? So we have the Ollama, and where is my actual model? Where's my record audio? All of these things should be in my main, actually. So here, right? So tool determiner, Ollama chat. So this is what I need to change, right? Okay. And so now the other thing is, I'm going to come in here. Oh, I already pressed the go button. Anyways, do you think I still need the catch where I have the try and finally and block with the os.system ? I was adding it based off of your suggestions when we were initially trying to do the keyboard pressed low on the spacebar, but now we have changed to a different methodology, and I'm trying to clean up my code a little bit, period. Okay. So we've pulled this, and it looks like is just very specific. We've already tried this, and it didn't work, right? The exact current tags here. So I don't think that this is... Oh, yeah, obviously. Okay. I don't think that this is going to work. Yeah, okay. So, but this phi one we don't really need as much because that one was the one that we were a little bit less excited about anyways. So I think it's fine. Computers. Okay, so deep dive into escape sequences. As a backend engineer, understanding how text is stored and represented is one of those level up moments. Okay, computers are essentially giant calculators. They only store numbers to handle text. We created Unicode. Okay, what is Unicode? It is a universal phone book that assigns a unique number called a code point to every character in the language, or every character in every language. Okay, so I guess my follow-up thing is question number 2 is going to be, I know about ASCII, and so now what is the difference between this idea of Unicode and ASCII? Question mark. All right. So we have the 中, like 中国, right? It means center, or the beginning of the word for, like, word. I don't know. It's 2 words together create the word China. So the way that Chinese works is every single syllable is a word, but then you can combine two words to make a compound word kind of thing. So like China is 中国, which means like middle or center, and then country. So you put those together, and you get China. And like America, 美国 is beautiful, and then country. And then 法国 is means like law. I don't know. But anyways, 法 and then country. And then it's not always two words. Like, for example, Russia would be 俄罗斯. But then you can also say, like, 俄国 and 俄, right? And then 国 is country. So that's Russia. Russia has two names. But yeah, so not all words are two compound words together, but it's usually compounded too. But anyways, you can also have this like, what's that going to be called? Animation. It's not animation. It's like emoji. There we go. That's the word. A Unicode escape sequence. Okay, so what is escape sequence? Is a way for you to write a character using its phone book number instead of the character itself. So in Python or C#, it usually has this /u followed by a 4-digit hexadecimal character. So why an escape sequence? Environment safety. Some older terminals or text editors can't render Chinese or emojis. Using this, it ensures that it won't break or show weird symbols. Okay, yeah, I've definitely seen like sometimes when I'm using older things, if I'm doing something in Chinese, it will just show like random gibberish garbage on my screen. I'm like, okay, well, that's not going to work. If you open up a system with limited font support. Okay, so logic and ranges. As you saw in our bilingual check, it's easier to tell a computer check if this line is between these two numbers than it is to list every single Chinese character with an if state. Yeah, that would be pretty bad. Invisible characters. Some characters have no visual representation, like a zeroth with space. So we have to escape to see that. Okay. So, real world examples. Bilingual filtering, the one that we did. So, yep. Between here and here, that makes sense. Handling emojis. So, happy face is, and then this, okay. So now number 3 is going to be here. I noticed two things about this, comma. The first one is, in this case, you used a capitalized U, comma. And the second thing, which I noticed, is that you have many more hexadecimal numbers in this configuration than we did when we were checking our Chinese characters, period. Okay. String sanitization. If you are possessing input from Whisper and want to make sure that there are no weird non-breaking spaces that might mess up your tool calling logic. Is a non-breaking space. User replace this with this. Want to make sure that there are no weird non-breaking spaces. Okay. What are these? Okay. My code strategy here. Okay. So now we're kind of getting into a little bit of the weeds of these and kind of away from this. And So let's... Should I... Okay, so we downloaded the models. Now, should we actually... We have this Mistral, right? So let me do this llama and then list. Okay. So now I have all of these, and I should be able to do this, right? Let's just try Quinn. Okay. Let's try Quinn. Let's come in here and let's run it in here. So I'm going to say model, and there should be 2 instances. Where's the second one? Here. Yep. Okay. So now, and I shouldn't hard code this actually. It should be a global parameter. So I'm going to change this. I'm going to say model equals whatever, LLM model. Okay. And now I'm actually going to come up here and change this. So I'm going to say here is equal to, and we need to snooze you. All right. And oops, come here, and I'm going to... Do we want to do Quinn first, or do we want to try this Mistral? Let's try Mistral first. Let's just see. Let's see what's up. Mistral, and we want this in there. There we go. And so now I don't want this. I want this to be LLM model. Okay. There we go. And so now I want to copy this. And let's do the same thing. Let's cat to this chat agent. Okay. Paste it in there. Exit out. And what are we going to try to do? We're going to try to talk to it. And so we changed the AI model. So it should act slightly different. Hopefully it won't do those weird tool callings. If that's the case, we need to change the system prompt. Then I want to also try speaking to it in both English and Chinese. Yes, so that's what we're going to be doing. Okay, so Python 3 chat agent. Okay. Hi, so I was wondering if you could tell me a story about a bear who is looking for something to eat. Okay, let's see if it calls a tool. It did not. Awesome. All right, let's see. It does need to load things into memory. I remember that the first time that you do one of these, it's going to take a little bit of time. So let's not get too worried yet that it's taking a long time, because the first time does take a little bit more. Okay, while it's doing that, I'm going to run this just so that we can multitask a little bit. It's taking a little bit longer than a long time. I'm not, uh-oh. All right, so since you've moved to a different methodology or similar, listens to, the answer is probably not, but with one big caveat. Don't print the characters the user is typing. We usually, oh, this is taking a really long time. Command tells the Linux terminal don't print the characters that the user is typing.
Of course. Here's a delightful little tale just for you. Once upon a time, in the heart of a dense, verdant forest, lived a friendly bear named Bruno. One crisp autumn morning, after a long hibernation, Bruno stretched his paws and yawned wide, ready to begin his search for food to replenish his energy stores. As he ambled through the golden-hued woods, he came across an array of delectable treats, ripe berries dangling from branches, plump acorns scattered on the ground, and even a few honey-laden beehives humming with busy bees. Yet Bruno felt something was still missing. Following the tantalizing scent of freshly baked goods wafting through the air, he wandered deeper into the forest until he came upon a quaint little village bustling with activity. As he peeked curiously from behind a tree, he spotted a group of villagers gathered around an open-air oven. Intrigued, Bruno approached cautiously and was greeted warmly by the villagers, who offered him a freshly baked loaf of bread. Bruno had never tasted anything quite so delicious. He gobbled up the bread with glee, his taste buds dancing with joy. Overjoyed to have found such a mouth-watering treat, Bruno decided that from then on he would make visits to the village a regular part of his autumn meals. From that day forward, he and the villagers shared delicious treats, forming a bond that lasted for many years to come. And so, our story serves as a reminder that even when we're seeking something specific, sometimes we may find even greater joys and friendships along the way. Just like Bruno, we can all learn to appreciate the unexpected wonders life has in store for us.
All right, there we go. So I'm going to try to do a follow-up in English again and see if that's going to work. By the way, I did want to point out one little thing of kind of like an observation. So today I at the very beginning of this video, like right before I started this video, I did take one of the supplements, right? And so it takes about an hour and 30 minutes to kick in, and I have not taken supplements for an entire week. So the last time that I took a supplement was last Sunday. And so I had that little, like, I was down for 3 days, 3.5 days, and then I was back to normal on Thursday, like Thursday night, and then Friday I was completely normal. Saturday I was normal, and so yesterday, I did a YouTube video, and I was working on this project, right? Yesterday I worked on the project, and so that was without any supplements. And so then today, I took the supplement at the very beginning of the video, right before, started making the YouTube video. So then an hour and 30 minutes, that was kind of like before any supplements had actually kicked in. And then obviously from that, the supplements started to kick in. And so that's something that I can look back on this video to see, like, okay, well, what are the changes? What are my observations? How did that actually, what did I notice any differences? So I'm just making that little note in this video so that I can come back to it and try to figure that out. Anyways, so we're going to come and actually talk in a follow-up, because I want to see, is it faster the second time? So what do I want to say? Like, okay, that's awesome. I want to say that's awesome, but that's awesome. How would it change if the weather was rainy, right? Kind of similar to what I did. That sounds like an awesome story. What would change if the weather was really rainy? Okay, so let's see if it comes up. By the way, notice again, it did not call the tool, which is good. Okay, and it is taking a long time, which, okay, it's taking a little bit too long. Like, this is not amazing. So, especially with this project, it's kind of...
Oh, what a fascinating question. In that case, our friendly bear Bruno might have faced a bit of a challenge in his search for food. Rainy days could make it harder for him to locate ripe berries or acorns, as they could become soggy and less appetizing. However, our resourceful bear wouldn't be deterred. He would likely adapt by seeking shelter during the heaviest rains and venturing out when there was a lull in the storm to forage for food. With his keen senses, Bruno might even track down some tasty fish or insects that thrive in wetter environments. In such circumstances, our bear's resilience and adaptability would only strengthen the bond between him and the villagers as they come together to overcome nature's challenges.
Wait, hold on. Why is it... Did it repeat it twice? Here and then there. It seems like it repeated it twice. Okay, anyways, now what I want to do... So that was a little bit longer than I was hoping for in regards to the response between when I asked and when it started responding. Took a little bit too long. I'm just trying to observe how the different models act in terms of their tool calling problems or lack thereof, their quickness, how they respond in terms of friendliness, and I'm just making observations of different models. So now I'm going to try speaking to it in Chinese and see if it can respond to me in Chinese. And it's also nice that it's printed here, so that way I can see what the LLM actually output, because if it outputted something in English, then we kind of know that the problem is within the actual LLM, that it's not responding back in Chinese. So what do I want to say? I don't want to mention anything about China because I don't want to bias the LLM towards Chinese. I want to only speak in Chinese and I want it to respond back. So I'm going to say maybe the weather is so nice. I want to go to the beach and enjoy the sun. I don't know. I'll just 乱说, just like randomly talk. 我觉得今天的天气真的是很舒服的。那我想去海边玩一下。Okay. Let's see if it was able to... Oh, they translated it into English. It translated it into English. Okay. So we have... That's where our problem actually is. So it picked it up.
That sounds like such a delightful plan. The cool, comfortable weather is perfect for a day at the seaside. I hope you have a wonderful time splashing around and enjoying the beautiful scenery. Don't forget to keep an eye out for any interesting sea creatures or shells that may catch your eye. Happy exploring.
All right, so let's quit it. Okay. There we go. And now let's wrap this up and send it over to over to Gemini and say what we have observed. All right, are we still recording? Yes, we are. All right. By the way, if we do randomly stop recording, I should maybe kind of do my outro right now. So if you enjoyed this video, please subscribe. I would love to have you on this journey with me. My name is Timothy Lee Grant, and yeah, so subscribe just in case the video like ends. I don't know when it's going to end, so I wanted to do my outro right now, and then we'll just keep going, and if the video does just abruptly end, well, okay, we got the outro anyways. But yeah, so let's just keep continuing. This is awesome. This is awesome. I love this. I love it. I love it. Seeing my character, my mood is so good. My mood is so good. And so what that is, why I was making that observation is because, like, obviously, as I just said, like a couple minutes ago, I took the supplements, right? And it's impacted my mood, and I'm very much like positive and interested in engineering and excited about engineering, which is kind of in contrast to what I was in the past. So that's why I'm making that observation. Like, my mood is so good. I'm so happy and this kind of thing. So just making some observations of myself right now. What happened was I started speaking to the model in English, asking it about a bear looking for food, comma. Then I followed up and asked it a second question about how it would change if the weather was rainy, period. The second one was also in English, period. Then something interesting happened, which was I decided to talk to it in Chinese, and I said that the weather was so nice and I want to go to the beach, period. But I said this sentence in Chinese, period. If you observe, this sentence was actually successfully translated into English correctly, and then the English translation was sent to the LLM, period. I don't want a translation to occur, comma. Instead, I want the actual Chinese characters to be transcribed, period. I'm actually pretty impressed that it, number one, recognized that I was speaking in Chinese, comma, captured my Chinese, comma, translated my Chinese correctly, period. But that's not actually what I was wanting, period. Okay, that's really cool. Oh, but we have not even looked at this. Okay, so, is this, anyways, so don't print this. If you keep it, your current function still, keep it if your thing still causes ghost characters or spaces to appear, or remove it if the new methodology handles, okay, whatever. If you want to keep your terminal clean but hate the dirty OS system calls, you can call with this Pythonic way of whatever. All right, ASCII versus Unicode. Think of ASCII as a small local library and Unicode as the Library of Congress. Okay, so ASCII, the legacy, is a 7-bit system created in the 1960s. It only has 120. Oh, I see. Okay. It covers English letters A through Z, 1 through 9, and basic punctuation. It's the bedrock of computing, but is completely blind to other languages. Okay, so the Unicode, a massive universal map that assigns code point to each character in existence. It has over 1.1 million possible slots. ASCII is the first 128 of the Unicode. Okay, means every valid ASCII also has a valid Unicode. Unicode is the map, whereas UTF-8 is the delivery truck. Okay. I kind of want to do this. I don't want. Okay, I'm gonna do that, and then I'm gonna come back up here and do my follow-up questions. Because if you do all of these follow-up questions, it actually kind of like lowers each question that you add. So if you have question 1, 2, 3, 4, 5, it's going to decrease the amount that it dedicates to each of those questions. So I'm just going to do one. I just wanted one question because I want a lot of detail on it. But I also want these follow-up questions. So now I'm going to do my follow-up questions. So that way I don't lose detail on the big question that I just asked. Okay, so this one I want to say, how does my code actually determine if I'm using the Unicode or the ASCII ? I think what's going to happen is just like it will always use the Unicode, but because the Unicode and the ASCII are overlapping from the first 7 bits, that means that if I only do like 7 bits, it will just do the same thing that would have been ASCII. Okay. And can you give me some examples of how I would use this UTF-8 versus other things? I want to see some examples. Because I definitely, I've seen UTF-8, I've used it many times, and I know that it is dealing with characters, but okay, I never took the time to actually like look into it. So I'm actually gonna go like this. Question number 2 is, I have seen this thing of UTF-8 many times before, comma, but I never took the time to actually dig into it and understand what I was doing, period. Can you explain more about this concept? Question mark. Okay. All right, so the capital U. For hex counts. Okay, so small u, this is for basic multilingual plain. It takes exactly 4 hex digits, okay? This covers almost all modern languages, including Chinese, Japanese, and Korean. The maximum value is these 4 bytes, okay? No, not 4 bytes, sorry. Just the 4 hex digits, yeah. It would be, what, 2 bytes, right? 1 byte, 2 byte. Okay. The big U. This is for extended characters. It takes 8 hex digits and is required for things like emojis, ancient hieroglyphics, obscure mathematical symbols that live beyond the 65,000 slots. Oh, okay. So non-breaking spaces. A non-breaking space looks exactly like a regular space, but acts like glue. In standard text processing, if a line gets too long, the computer looks for a space to break the line and start a new. Oh, I see. A non-breaking space tells the computer, do not break the line here. Okay. Units. You do not want 100 at the end of the line and kg at the start of the next line. You use a non-breaking space. So 100 non-breaking and then kg. Oh, okay, so it glues them together. Mr. Grant together. Ah, it knows me. Sometimes when you scrape text from web, you get this character instead of regular spaces. If your code does split, it will fail to split. Okay. Okay. So now we're going to come here and fail by the system. What happened is OpenAI's Whisper, this one, has a built-in translate mode, which I don't want. By default, Whisper is told to transcribe, but optimize for English-only output. It would detect Chinese speech and automatically translate it into English before giving you the text. It's a powerful feature. But if I'm looking for a truly bilingual agent, it's blocking me, yes. So in my transcribe function, you are likely calling whisper.cpp binary with the tr flag. I don't know if I am. Let's go and check that out. So record audio and transcribe. Transcribe. Okay, so I'm running this process here. Okay, with the T flag right there. Yeah. Okay. To fix this, you need to make 2 changes to the command. Switch the model. You must use the multilingual model. Do not run the .en. I'm not sure if I am. Okay. I am going to. Okay, so this is number 3, and I am going to give my transcribe here. Okay. Like that. And up here, where do I actually put in my whisper? Right there. Okay. Okay. So now come up here, and we're going to go like this, there, like that. So am I using, I'm doing the, I think this one is the right one. Global, right? So G base Ben, yeah. Okay. You should explicitly tell Whisper to perform the transcribe task and ideally let it auto-detect the language. Okay. Transcription command there. Notice I removed any.en. Where are we doing this? I'm not doing that. So what are we think? Are we on like 3? Okay, so 4. I don't think that I'm doing this command. Period. I don't think I'm doing this one. Okay, so okay, I noticed this. Make sure that you remove the extra U. Yeah, we got that. We got it. Okay. And yeah, so is the speak. Everything looks good, and let's do that. Okay. Still recording? Yes, we are. So I'm definitely starting to get a little bit more tired. I can feel that my brain is a little bit frazzled. And it's more difficult for me to really think right now. Okay. So since you're seeing English, okay, so how to, in Python 3, every string is Unicode by default. There's no such thing as ASCII string. Okay, type anymore. Only string and raw bytes, raw binary data. Okay. When you run result strip in your transcribe function, Python takes the raw bytes from whisper.cpp and decodes them into into Unicode string. Python checks the numeric value, the code point of each character, the threshold. If a value is between 0 and 127, it's part of the ASCII range. It's just standard English letters. If it's higher, then it's higher. There's no problem. Your code isn't choosing between them. It's simply looking at the numbers assigned. Okay, great. So it says A is 65 and was Hun is like 27,721. Is the envelope. It is the method to write those numbers down so the computer can read them efficiently. So Unicode 8. I feel like there's more things that I need to look into for the Unicode 8, but I can kind of feel myself a little bit winding down, and it's kind of hard to focus right now. So that's something that I'll need to look into in the future. Okay. The reason you're getting here is likely due to the, I think I need to remove this. In my current code, you're missing the flag to tell Whisper not to translate. Even if you use a multi-model thing, try updating it here. So TR, no. Do not include TR, which transfers translate. Okay. Verify my command. Whisper here. int. I have the int, right? This is speak.我在找啥? Okay. Transcribe. This is what I'm looking for. I have this int right there. Okay. -L and auto. So int and then whatever. we'll just copy and paste these. L and auto. Okay, I'm not sure about this. I don't know what that's actually doing, but okay, fine. Let's come in here and do this here, right? And paste all of that into there. Control D and run it.我觉得今天的天气真的是很舒服的。那我想去海边玩一下。Okay, let's see. Come on, Chinese, show me Chinese. There we go. 我觉得今天的 okay, well, it didn't recognize my accent, but that's fine. All right. Let's see if
太棒了，好像有机会花些时间放松自己很幸运。我知道一个很酷的海边景点，想要分享给你吗？它在南部海岸，名为美丽的明尼阿波利斯公园。这里有一条长达4-5英里的沙滩以及一系列漂亮的小岛屿和景观。如果你感兴趣，我可以告诉你更多关于它的信息。
Yes! Yes! And notice, well, I don't know, unless you speak Chinese, you wouldn't notice this, but it responded in the model that speaks Chinese. So in the previous one, when we were using that English model, it would attempt to say those words, right? Like nai ho or something like that. It would say it just completely wrong because it had no idea how to actually pronounce those words. This one was correct. This is the correct way of speaking Chinese. So it also used the correct model for Piper and got it. Okay, so let's say thank you once more. And so let's give this and say copy you, and I'm actually going to quit this and say once again, thank you so much. It is working. There we go. Oh my goodness. That is amazing. Look at that. Oh my goodness. Okay. Didn't choose a model. Okay, so awesome. Look at this. So it actually did this. It's very clean, right? There are no spaces. Unlike English, Chinese doesn't use spaces to separate words. This is why tokenization is so much more complex for Chinese than it is for English. But I mean, it's working. It's working. That is so cool. That is so cool. Okay, here we go. We have to do it, right? Git add. Git commit -m. I have successfully added Mandarin Chinese into my agent, period. The user is now able to speak to the device in either English or Chinese, and the model will recognize the language that they are speaking, comma, answer the question appropriately, comma, output everything in the language which was used, comma, and then select the speaking model for the appropriate language to correctly respond back to the user in either English or Chinese, period. Oh my goodness. Oh my goodness. Look at this. Git push origin main. Go. Yes. Yes. This is so cool. Okay. And this is only one of the models. We still have the Quinn. We haven't even tried the Quinn yet. Oh, that's so cool. I'm like really happy with the results of today. I want to keep going, and I don't like, where do we go from here, right? Like, I guess we can. Are we still recording? Yes, we are still recording. Okay, great. Obviously we need to clean up a lot of stuff. That's one of the things that we need to do. Should we go and start looking in like how things are working, like if we are confused about anything? I know that we have this like tool prompt. I mean, this one is working, so no need to change something that's already working, right? This might break if we provided a tool in Chinese. We haven't tested that yet, so that's something that we need to realize. Okay. So the enumeration of the devices is, yeah, that's what we're doing. It's fine. Audio recording, this is working. Okay. So should we look into okay. We're opening up a pipe, right? And we're reading that stream, going into data. We're just capturing the chunks of like audio files or audio data, which is like 100 or 1,000 samples or something like that. What was chunk defined as? Yeah, 1,024. So that's 100 or 1,000 samples, and that's stored in here, and then we're appending that to frames, so that's just a list. And then we keep on going, and we have this, but we didn't even change that yet. Audio, record audio, okay. Transcribe here. So we're actually not even using this record audio anymore, right? Because we're doing this record audio worker. And so, okay, let me actually go in here and then delete this record audio. Make sure that we're not using it anywhere. Let me move myself out of the way. Record audio is, okay, so let's come in here and just delete this because we're not using it anymore. It's just clutter. Come on. Ah! Okay, that's one of the problems with working on a laptop. I much prefer a desktop. I have my desktop behind me, right? And I can have my mouse, and you're able to just like use it a lot better or a lot easier. Although, like, oh, come on. Record audio. This is what I want to delete, right? Yeah, record audio. So I'm just going to go ding. And then I'm going to go ding. And we should be good. There we go. Okay, so got this. And now I am going to... Okay. So we did the transcribe. Maybe I can even put myself right here a little bit. Does it block this? I mean, it kind of does. I I feel like I'm gonna be in the way no matter what. Okay. So we did that. This is recording. That's fine. That's fine. Press. We're able to get all of this like knowledge-based stuff. And maybe the next step is we need to have it call tools, maybe. Do we want to try the different model? Do we want to go and see if we swap out this Mistral for another thing? So let's just copy this, right? And do this, and then just hashtag this one out like that. And I don't need this one. Import keyboard, not anymore. Okay, so now instead of this one, I want to do Ollama list. Okay. And we're going to do this 7 billion parameter. Now, something... Okay, so they're about the same size, so I'm guessing that the latency is going to be very similar. And then another thing that we could try doing is trying this like Llama 3.1 and Llama 8 billion, because we were using this one right here, I believe, the 3.2, which is only 2 gigabytes. So perhaps that was one of the problems that we were facing. Anyways, put you in there. Copy everything in here, and I am going to cat you into chat agent. Okay. Python 3 and chat agent.py. Okay.你可以告诉我一个很有趣的故事，关于是龙吗？ I don't know. Tell me a story about a dragon. I don't know if I said that correct, but 龙吗? Okay, yeah, it got it. And this is Quinn, remember. So it's going to take some time because the first time is always a little bit longer, right? All right. So another thing that I want to do while this is thinking is I noticed that the voice for both the English and the Chinese is the same person who is talking, period. Are there other options that I can use? Question mark.
当然可以，这里有一个小故事，希望你会喜欢。很久以前，在一片遥远的森林里，有一条会说话的小龙，叫做云翔。与其他暴躁凶猛猛的龙不同，云翔非常友好和聪明。他有一颗好奇心旺盛的心灵，并且总是梦想着探索世界。一天，云翔听说，在世界的尽头有一个美丽的花园，那里充满了各种奇花异草和闪耀的宝石。虽然路途遥远，而且充满危险，但他决定踏上旅程去寻找这个传说中的地方。他的旅途并不容易，途中遇到了狂风巨浪、险峻山峰和狡猾的雾，是但凭借智慧和勇气，云翔一一克服了这些困难。最终在一片开满五彩花海的地方，他找到了那个传说中的花园。花园里的花朵散发着令人安心的气息，宝石闪烁着柔和的光芒，各种各样的神奇生物在那里和谐共存。云翔在那片仙境中度过了许多快乐的日子。最后，云翔把花园的秘密带回了森林，并与朋友们分享这个故事。从此以后，云翔不仅成为了森林中的英雄，也成了所有生物的朋友和探险家。他的故事激励着后来的冒险者们勇敢地追求自己的梦想。希望你喜欢这个小故事，
And then I'm just going to ask it to continue. 你可以继续告诉我这个故事吗? Because I want to see how fast it takes before, because that was the first time. Now we're going to do it the second time, right? So the entire model should already be in memory. So let's see how long it takes it to load up and actually get a response, right? So see, this is taking a very long time. So I'm a little bit hesitant on how long this is taking, because if we're going to have like a dynamic conversation, this timeout right now is not very acceptable. So we might need to figure out how we can speed things up. And one of the things that I'm thinking is, while it's generating these things, right, maybe we have it talk while it's generating, while it's continually generating.
当然可以，让我们接着讲云翔的故事吧。在花园里，云翔遇到了一只名叫彩霞的小精灵。彩霞有着彩虹般绚丽的头发和一双闪亮的眼睛。她告诉云翔，花园里的秘密花朵能够实现一个愿望，但必须通过一系列考验才能找到它。为了帮助云翔完成这个心愿，彩霞决定陪同他一起踏上寻找秘密花朵的旅程。他们穿过了一片迷雾森林，一座高耸入云的城堡，并最终来到了一处隐藏在瀑布后面的神秘洞穴。在这个洞穴里有许多发光的谜题需要解答。云翔和彩霞小心翼翼地解决每一个难题，逐渐接近那个传说中的秘密花朵。就在这时，一个狡猾的老巫师出现的，他嫉妒云翔的成功，想要阻止他们找到那朵花。老巫师设下了一个巨大的考验，他要求云翔回答一个复杂的问题：如果你可以改变世界的一件事，你会选择什么？云翔想了想，微笑着说：我希望这个世界上的每一个角落都充满和平与友爱。老巫师被这个答案打动了，决定放过他们。于是云翔和彩霞顺利找到了那朵秘密花朵，并共同许下了愿望。当愿望实现的那一刻，整个森林都被一股温暖而和谐的力量笼罩着，所有生物之间的关系变得更加紧密，森林也因此变得比以往任何时候都要更加繁荣美丽。从此以后，云翔不仅继续他的冒险之旅，还成为了森林中的守护者、保护者，所有的生命免受伤害和不公。彩霞也成了他最好的朋友之一，陪伴着他经历了许多难忘的时刻。这就是云翔的故事，关于勇气、友谊和实现美好愿望的故事。希望你喜欢。
All right, there we go. Okay, so that's how long it took, right? So we're just kind of getting data points right now. Okay, so it's the exact same voice, right? Like it's this kind of robotic female voice for both the English and the Chinese. So I'm just trying to explore my options. Another interesting thing which I am thinking about possibly doing is to be able to clone my own voice and have my voice be the one who is talking. Period. What do you think about this? Question mark. All right, let's see. So, okay, so Piper handles different models, even though the file names are different. Many of the open source datasets used to train these models sound similar, and they are optimized for clarity on low power hardware devices. Okay, finding other options. So Piper is actually very flexible. You aren't stuck with LESIC or Huayan voices. You can browse the official Piper directory to find different personalities: male, female, soft, energetic. So for English, you might do EN, US, Amy, medium. So English, United States English, the person is Amy, right? And it is a medium-sized model. So a common, clear female voice, or US Bruce is a deeper male voice. Okay, so for Chinese, oh, that's funny. They actually have CCTV. So what CCTV is, it is like China's official government news broadcasting agency. And so the way that they talk is very formal, and they pronounce their words very accurately. So this is why that you would be interested in using like the CCTV version of the Chinese language. So which sounds more like a news broadcaster. Exactly. Yep. So all we would do is download the Onyx and the JSON and then update my paths. Okay, so look for quality tag, low, medium, high. For the Orin Nano, medium is the sweet spot, sounding like a human. Okay, so cloning your own voice. So video or voice cloning, often called zero-shot TTS, is a huge level up for AI agents. Having your own voice talk back to you is both cool and a little surreal. How it works technically. Instead of using pre-baked model like the ones you are using now, I'm just making sure that I'm still recording. Yes, I am. Okay, cool. A cloning system takes a small embedding, a mathematical fingerprint of your voice, and applies it to a base model. Okay? So, since you are running locally, you have a few paths, but they are much heavier than Piper. Never mind then. Never mind, we're already struggling. The catch, they require more VRAM than Piper. Never mind. Pros, personalization, it feels like your own twin. Okay, the latency, so we're not going to do it. When you clone a voice, the computer isn't saving sound, it's saving a vector. Okay. Another thing that I am noticing is now when I use the models such as what? Such as these two. It definitely does have a much longer wait before the time when I finish my audio recording and when the response actually starts talking to me, period. I need to wait about 30 seconds, period. Okay, and now actually I'm just going to delete this so that it should get this. Okay, so unified memory congestion. When you move the 2 gig model, you are leaving a little bit of breathing room for the rest of my pipeline. Okay. So why the delay is happening? Since your 8 gig of RAM is shared between the CPU, loading 4 gig plus Whisper might be pushing your swap here. Model loading time. If Ollama isn't keeping the model hot in memory, it has to pull those 4.7 gigs from your SSD every time. Okay. How to get my speed back. I guess the first question is going to be, what commands can I do on my Nano Jetson to see which of those problems you mentioned as potential problems are actually reality? Question mark. How do I check these? Question mark. Okay. So yeah, this is good because it tells it not to unload. Exactly. However, if you're calling 2 different models, I'm not calling 2 different models. So I'm going to say number 2 is I am not calling 2 different models. Okay. Yeah. So context window, if your is getting too long, I don't think, and I don't, and my, it's not, I don't think, and my context window is not getting too long. I can say, as you can see, the 30-second pause which I am talking about occurs when I send my second message to the LLM, period. And then I actually want to just copy and paste this, right? We're okay. So we can go like this, has all of this, and I'm just going to copy and paste here. Okay. All right, so like that, right? All right, so monitor it real time, open up a second terminal, and then do this. About the voice cloning, so I'm going to say 3. I decided not to do the voice cloning because I heard you say that it takes a massive penalty in speed and RAM, comma, both of which I am unwilling to take because it would significantly degrade the quality of my project, period. So I'm going to keep it with the official release versions of Piper, period. Okay. So I'm not going to do this because then we're calling those random tools. Okay. So how do I check these, and what are the steps I should look for? Okay, there we go. We'll do that. I know it's going to want me to open up a second tab, so I will do so. And let's see, make sure I'm still recording. Yes, I am. New window. All right. And we want to do SSH, Jetson. Here we go. Jetson. There we are. And we're going to do JTOP from this one and then run our Python from this one. Okay. First, we want to do this. All right, so JTOP, yeah. So we want to look at that mem again. And turns red. Memory is pressure limited. Swap if the number of... Okay. So, all right, let's come here and let's do JTOP first off. Okay. And now I want to come in and look at 4, and we are going to be seeing this swap, right? Okay. And we're going to be looking at this. Okay. So, right. Let me, I'm going to say right now, as of right now, comma, when my Python is not running, I see my JTOP mem as, comma, used 5.6G, comma, GPU sh as 4.7G, comma, buffers as 16.8 M, comma, cached as 1.5G, comma, free as 394 M, comma, TOT as 7.4G. What do each of these mean? Question mark. Okay. All right, and then I see something in here. I see, okay. I also see somewhere else on the same MEM screen as swap, which has 196M divided by 3.7G. Okay. Like this, right? G, and then cached is 1.4M, like that. What do these mean? Yeah, okay. So now what I want to do is I'm going to say watch the GPU load spikes. If it goes, okay, so now GPU load. Is there something that actually just says GPU load here? I know that I have the GPU there, so I could go here, but we might need to do that in multiple things. Okay, so Ollama PS. Okay, check size. Okay, so when you send this here, your code quite long, right? A long time ago, even though is a sliding window, it is currently commented out. Yeah, but I don't think that's actually the problem. Okay, so let's run this and just see what we see, right? I'm gonna get this a little bit. There we go. Okay, so let's run my Python. And what do we want to ask it about? Let's ask it about another story. What kind of story do we want to ask it about? Let's do it in English, so that way we can... I mean, my videos are in English, so it kind of makes more sense that I say it in English. I'm gonna ask it about a story. I'm gonna do the bear thing again. Can you tell me a story about a bear which is looking for delicious food to eat? Okay, now let's see how it changes. All right, so it is, seems like we're doing okay, right? Let's look at the, oops, let's look at here. And what do we see? We see CPU right there. Let's go back to 4. I don't see anything real. I don't see swap. I don't see much changing there either. The GPU here, nothing. So used is the 5.6G. iGPU is at 100%, right? Okay. Come here and put this a little bit more towards this way. Now when I am running my program and it is generating the text, comma, I am seeing...
Of course. Here's a little tale for you. Once upon a time, in a lush green forest, there lived a bear named Bruno. Bruno was known throughout the land for his love of good, hearty meals. Every morning, as the sun painted its first light across the sky, Bruno would awaken with a rumbling growl from his empty stomach. One crisp autumn day, Bruno decided it was time to embark on an adventure in search of delicious food. With his bushy tail wagging and paws padding through the fallen leaves, he ventured out into the forest. The air was filled with the sweet scent of ripe berries and nuts, a feast for any bear's appetite. As Bruno wandered deeper into the woods, he stumbled upon a clearing where the ground was littered with colorful mushrooms and juicy berries. his nose twitching in delight. He began to explore, picking and sniffing each morsel until he found his favorite, a large, plump raspberry bush. Bruno sat down contentedly as he enjoyed his breakfast. After satisfying his morning hunger, Bruno continued his journey. He soon came across a river, where fish were swimming lazily in the clear water. With a playful splash, Bruno entered the river and started catching fish with ease. His belly began to feel full again, and he swam to the shore, satisfied but not quite content. Determined to find more food, Bruno followed the winding path through the forest until he reached an old oak tree. Nestled at its base was a fallen log, and beneath it lay a treasure trove of acorns and nuts. Bruno spent hours feasting on his discovery, his paws full and his tummy warm with the satisfaction of a well-fed bear. As night began to fall, bringing with it a cool breeze and shadows in the trees, Bruno realized he had found not just one meal but enough for several days. With his stomach content, he made his way back home through the forest, leaving behind only footprints and stories of his adventure. And that's the story of brave Bruno, the bear who found delicious food on a sunny autumn day.
That's an awesome story. Can you keep telling me more about it? Okay, so let's see if this changes. So it's generating it right now. So nothing is really changing. I'm not seeing anything really change. Okay. This when I ask a follow-up question, I still do not see any changes on my JTOP telemetry data, period. Okay. Now, so it's still generating it. Let's come back to here, okay? And it's doing its thing. And we can come to 2, and now it's at, I saw 21%. Okay, so it's actually toggling a little bit. 66. I can say, I see it toggling between 100%, 0%.
Absolutely. Let's dive deeper into Bruno's adventure and explore some more details.
This.
Once upon a time, in a lush green forest, there lived a bear named Bruno. Bruno was known throughout the land for his love of good, hearty meals. Every morning, as the sun painted its first light across the sky, Bruno would awaken with a rumbling growl from his empty stomach. One crisp autumn day, Bruno decided it was time to embark on an adventure in search of delicious food. With his bushy tail wagging and paws padding through the fallen leaves, he ventured out into the forest. The air was filled with the sweet scent of ripe berries and nuts, a feast for any bear's appetite. As Bruno wandered deeper into the woods, he stumbled upon a clearing where the ground was littered with colorful mushrooms and juicy berries. His nose twitching in delight, he began to explore, picking and sniffing each morsel until he found his favorite, a large, plump raspberry bush. Bruno sat down contentedly as he enjoyed his breakfast. After satisfying his morning hunger, Bruno continued his journey. He soon came across a river, where fish were swimming lazily in the clear water. With a playful splash, Bruno entered the river and started catching fish with ease. His belly began to feel full again, and he swam to the shore, satisfied but not quite content. Determined to find more food, Bruno followed the winding path through the forest until he reached an old oak tree. Nestled at its base was a fallen log, and beneath it lay a treasure trove of acorns and nuts. Bruno spent hours feasting on his discovery, his paws full and his tummy warm with the satisfaction of a well-fed bear. As night began to fall, bringing with it a cool breeze and shadow.
Okay, we get it. That's fine. So I'm going to press this, and it's definitely a very long story. Alright, so maybe that's why it's taking so long, is because it's a very long story, and it's just like goes on forever. Okay, this is excellent. And I also noticed that it needs to do 2 things for like tool calling, right? So I'm actually, within that 30 seconds, I'm doing 2 things. I am calling the tool determiner, and then I'm also calling the chatty one, which is, it's the same LLM, but it needs to generate things twice. Okay, so because the Orin uses unified, okay. So pre-flight state, before Python runs, it's here. This is the most important number. Even before you start, the script is 75% of your RAM is gone. It's likely because Ollama keeps the model. Yes. Confirms that it's holding it, right? Inside of RAM on Jetson. Okay. This is great news. It means the model is running entirely on GPU cores. If it were low, CPU is doing toggling. This represents the token generation phase. The GPU spikes to 100 to calculate the next word, then drops. Okay. To send the word to your terminal or Piper. JTOPS isn't showing the massive spike during the second message. So this has claimed the model is in the right place for speed. So it only has 2 GB left. Since you've confirmed that your model is the GPU RAM is tight, here are the best 3 ways. Lower the model size. We're not going to do that. Use the flash attention. If your version of Ollama supports it, there's a more memory efficient way for the GPU to read the conversation history's aggressive sliding window. I'm going to say here, one of the things that I'm thinking is that I'm actually calling the model twice, and you see I am calling first time with the tool selector, and then I'm calling the second time for the actual chatting agent, period. So within that 30 seconds, I'm actually calling the model and getting a response twice, period. The other thing that I'm noticing is that if the output of the LLM is really long, comma, meaning it gives me a very chatty story, then I need to wait for the entire model to finish generating the story before it even starts sending things to Piper so that I can start hearing the story, period. I think both of these things are causing a delay in my system, period. Okay. So let's see what that says. All right, so yeah. So in here, tool calling, wait for it to pre-fill the prompts, return a JSON-like tool call tool, wait for the LLM, everything all over again. Because you have almost no free RAM, every time you start a new Ollama chat call, the system has to work in... So KV cache, I remember we were talking about this, but does it actually apply in my case? You don't need a separate intent classifier prompt. You can provide the tool calls directly to your main prompt. If the LLM sees it needs a tool, so we'll cut the wait time by 50%. Okay, so first thing is, can you tell me more about the KV cache and why I am incurring this penalty? ? Notice that I am having the exact same model in my RAM. I'm not loading it twice. So I have the which I simply invoke for both of the ollama.chat calls, period. Okay, so combining them. Let's see. You don't need separate intent classifiers. So I am going to slightly disagree with this because, and maybe we do. Okay, so hold on. I'm gonna go use the restroom again. I've been drinking so much like coffee and everything. Okay. So. Alright, so we are back. Am I still recording? Yes, I am. Oh my goodness, that is amazing. Okay, so combine them. Why you don't need... The initial reason why I used this approach was because I was experiencing the problem where the model would know about tool calling and it would always try to call the tool, period. So what I decided to do was separate the logic such that it would not even know about the tools in the chatty version and only be responsible for calling the tools in the tool caller version, period. Now that I changed the model, I might not need this, period, but that is the reason why I was doing it, period. What do you think of this, question mark? Okay. So that's that. So wait for the end. Right now your code is synchronous, so it's blocking, right? This waits for the LLM has typed the entire story about the dragon before it moves on to the next line of code. If the story is 300 lines long, you're sitting in silence while the Jetson slowly calculates every single word. The fix is streaming. Okay, so I think we're going to be doing this in the next video, but I'm just kind of getting an idea of where we might be going into the future. So you want the LLM to send you words as long as they are generated, as soon as they are generated. You can collect those words into sentences and send them to Piper immediately. This way the agent starts. Okay, actually that is really cool. So this one is going to be number 3. Can you show me how I would do the streaming? Question mark. All right. Oh, maybe it shows me right here. Refactoring for speed. Here's how you can refactor the logic to solve both problems. I've merged the tool use into the main code. Okay, so LLM payload messages, and we can kind of go into this later in the next video. Okay, so I have my chat there. Whatever. Yeah, so we'll have to kind of investigate this. This seems more like a tomorrow, not tomorrow because I'm going to be working, but next whatever Saturday kind of problem for chunk in response. Yeah. Okay. Awesome. Okay, so let's let me talk about this and let's just see what it says about the KV caching. And then once we are done with that, we can kind of end out this video. So let's look at it. So You're balancing precision, making sure that the LLM doesn't hallucinate a tool with latency, making sure that the response feels instantaneously. So the mechanical why behind your 30-second wait. So the KV cache. Why the same model does not equal no penalty. You are correct that the model weights, the 4.7 gigabytes of Qwen, stay in RAM. However, the KV cache, so key value cache, is the scratchpad. Oh, right. Okay, I remember something about this. The model uses to remember what has already been said in the current conversation. Right, okay. So think of the model weights as a library of books and the KV cache like a whiteboard. Okay, the model here, the KV cache is dynamic and temporary. Every time you hit ollama.chat, the model has to reread your prompt. For every word token it reads, it calculates a mathematical representation and writes it on the whiteboard. So it doesn't have to calculate it again. Okay, so the penalty on my Jetson, the whiteboard space is limited. When you call the model for the intent classifier, it fills up the chunk of that 394 megabyte free RAM with whiteboard data for the specific prompt. Then when you call it again for the agent, it clears it. Okay. Even though it's the same model with prefill phase, reading the prompt has to happen twice. Got it. Okay, so tool obsession problem. Your reason for splitting the model was valid. Older and smaller models often suffer from tool bias. If you tell them that they can use a hammer, they always use a hammer, right? So Qwen 2.57 billion is much smarter than the models that usually have this issue. It is specifically trained to be better. So we might be able to get away with not using that architecture. How to fix the tool obsession without debugging. Instead of a separate function call or separate call, you can use negative constraints in your main system prompt. Okay, so we can do something like you are friendly assistant. Okay, so critical, only use tools if the user explicitly tries or asks for it. So we can try this in the next video. The stuttering or blocking factor. The 30-second pause is also a result of batching. When you call the model twice, you are essentially asking the Jetson to perform 2 cold starts in a row. If the second call is a 500 token long, or if it's 500 tokens long, the Jetson spends 10 seconds classifying the intent, 5 seconds processing the result, 15 reading. Okay. 30 seconds of total silence. It's suggestions. Since you're a software engineer building a real-time agent, you should prioritize streaming above almost everything else. If you switch to streaming, the user starts hearing the story while the LLM is still writing the end of it. Even if call 2 takes 15 seconds to finish, time to first word, which is when it starts generating, might only be 3 to 4 sentences. Okay, so awesome. We have a direction for where we're going to be going. So let me make myself a little bit bigger while we do the outro. All right. So what we are going to be doing is I'm going to be ending the video here, and then in the next video we are going to be exploring a lot of different ways that we might be able to make this model a lot faster. So the first one that we're going to be doing, as it just mentioned, is streaming. So while the LLM is generating the tokens of the story, we are going to be immediately sending that out to Piper so that it can be saying it to us. And that way we are able to we are going to ask the question, the user's going to ask the question, and then all we have to do is wait for the time to first token, which is the time at which the LLM starts generating the tokens. Some problems that I foresee that could occur is if Piper is trying to talk faster than the LLM is generating each token. Now that might make it sound very strange and choppy. So that's a potential problem, but we'll see about that. So that's idea number one that we're going to be moving forward on. Idea number two is going to be seeing if we can actually shrink the two prompts that we have right now into one single prompt. And in the past, what I was doing is I had those two separate prompts because the model was really bad at identifying if a tool was required or not. It was always trying to invoke a tool even if it didn't need a tool. Number two, it was trying to invoke a fictitious tool. It was just coming up with a random tool that I didn't even say it had access to. And number three, it was invoking the tool incorrectly, even if it needed a tool. So we're going to see if we can collapse that into a single prompt and see if that is able to move us forward and decrease our time. And then we can also learn about KV caching and how that actually impacts our project. And so we have a very interesting path forward right now, and we're going to be learning a ton of very interesting things. So if you want to join me on this journey, subscribe. I would love to have you along, and we can do this together. So yeah, subscribe. Thank you for watching. My name is Timothy Lee Grant, and I am very happy about the state of this project. I am now able to get it. I can speak to it in English and speak to it. It goes, does what it needs to do, doesn't call the tool if it doesn't need it. It then responds. That's translated into speech, and I can hear it, and I can have a dynamic conversation with it. Number two, I can also speak to it in Chinese. It does the same thing and responds back to me in Chinese. That is amazing. Today was a very, very, very good day, very productive, and we got a ton done. So yeah, thank you for watching. Subscribe if you want to, and have a wonderful rest of the day. All right. I wonder how long this video is. I have no idea. I don't know when I started this video, and I don't really have a timer. All I see is like, essentially it's 7 o'clock. That's all I know, is that it's 7 o'clock, but I can't really remember when I actually started the video. So anyways, yeah, so thank you for watching, and goodbye.